In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice, a flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his...
All right, hello and welcome, lads and ladettes. We're going to be joining the Friday community Twitter space hosted by Brian Sweet and Kenbo, our two local Flat Earth heroes, holding it down every week. We're going to see what they're up to over here. And Shane G's already in there.
I've never seen anything. I've never seen a pendulum set up with a motor, and then not process over the same period that the other measurements are saying they're processing according to latitude, and that would be required by the claim that actually pendulums prove the Earth is rotating. So I don't know.
I mean, wouldn't every single pendulum on Earth do that?
I work with a lot of cranes, and when they're not in motion and we're not doing anything with them, and that big heavy headache ball's hanging there, kind of like a plumb bobble, I guess would be a pendulum too, right?
Yeah. Buried. What's up, Alan?
Yo, what's up, lad? Speaking of giant swinging heavy metal balls, there's a guy on YouTube named...
That's a nice segue.
His name is On the Level, I think it is, or something, or no, not On the Level. I can't remember. He's from England, but anyway, his whole channel... Oh, it's Leo. That's his real name. Anyway, Level Earth Observer. That's what it is. That guy was a crane operator, a big industrial heavy crane operator, and like they're very, very sensitive. They can feel vibrations like, all the way down, multiple city blocks away and stuff. And when he's up there, they're just not feeling any rotation effects. There's nothing up there causing any issues. Yeah, and he goes on to make one of the biggest points that if you're on an inertial reference frame, or I'm sorry, a non-inertial reference frame, like if you're on the thing that's in motion rotating, it's going to cause that pendulum to move even when there's nothing, causing it to move. So the fact that all these giant crane balls remain stationary when they're not in use, like they don't just start processing on their own, nothing here is feeling the effects of Coriolis in that regard. So, or any sort of force, rotational force.
Oh, that's why it's fictitious.
Indubitably.
Indubitably. I fucking love it. I love it, man. Yeah, none of those big steel balls fucking swing on their own. I'll tell you that. I've been working with them my whole career. Weird. Indubitably.
I heard you talking about the ether pherometer earlier.
Yeah, dude, well, I think Kembo was doing a great job explaining. I think I heard him do time dilation in 15 seconds, which was amazing. Explain how that was retarded with time to the function of atomic clocks and how cesium oscillates at the rate, how that's used to maintain the magnetic field of the frequency to specifically keep it in sync to go against time dilation. And then we did some other cool stuff. And then I was generally asking people how they can, have an interferometer that can detect axial rotation at 0.46 kilometers a second, but definitely can't detect motion at 30 kilometers a second. I was wondering if
bro, they go as far
framework to explain that one to me.
They go as far as to say they can detect nutation, like that little baby oscillation or whatever that happens.
Wobble, yeah.
Yeah, that wobble within a wobble's wobble. They say that they can detect that with an interferometer, but Earth's orbital velocity, dude, never matter.
Dude, no. Well, look.
Dude, when did they detect the wobble, man? When do they do that?
I mean, that's what they say. They say they're out there wobbling it.
Catching that wobble, man.
But speaking of wobbling, welcome back, Stone G.
Yo, hey. Great to be back. Many thanks. Nice. How's everybody doing?
Doing good, man. You got to give me a follow back, man. It's a new account.
Oh, well, shit. Alrighty.
Yo, it's on now, Globies. Get you guys up here now. Let's do it.
I find it funny that, Mr. X brought him up here, but he was up here talking all this fucking bullshit. And the moment you came up here, he left.
Who did?
Peter.
Screw that guy.
Yeah, I
I'm
know.
waiting.
That's why I said I didn't bring him up, but he
No,
was.
dude, no. Inshallah, he leaves when we come. That's.
Well, I
He
think
makes sure
so
everybody's
too.
twice. Yo, he
Yeah,
had
I
me
got a whole
twice,
new
yo, bro.
guy.
But you know what the other guy had tied? It was almost tied, that annoying Brian, actual flat earther, agnostic or whatever. I'm like, dude, you're close, man. I'm telling you, man.
I don't think he was a real flat earther. I think he was a glober pretending. Like what he said was what I think a glober thinks flat earthers say all the time. Like that's kind of a glober flat earth.
Yeah, his need to say something every 3 seconds was working my nerves.
Well,
Yeah.
I've been hearing a lot from this new guy, Proxy Party. Did you guys come across him last Friday?
Yeah, it does sound familiar, man.
He claims that he ragdolled the whole group of you, looking
Yeah.
for somebody else
Wouldn't
more
this-
worthy.
Get him
of
back in
stuff.
here. What's his tag?
It's at Proxy Party 247, all lowercase. He's been yanking my chain all week, asking me really dumbass questions.
At Proxy 247?
Yeah, at
You're saying
Proxy
he
Party.
manhandled you?
Yeah, at Proxy Party 247. Yeah, he thinks he's just gonna body bag me here. It's so awesome that we're all right here to witness this. Should he actually show up? And here's another one. 9 hours ago, he's like, "Is he going to be here today?" I'm like, he's tagging Shiva.
Dude, I just tagged him, man.
He's tagging Shiva like he's going to bring Shiva to our space or something. Like, that's never going to happen.
He does sound familiar. He might have been in here. It does look familiar, but I just tagged him in the purple pill. So I ain't gonna lie. I am getting a bit cocky, and I can be put back in my place a little bit. So if you can do that, I appreciate it.
I could use someone worthy to talk to, but I got a feeling this just ain't it. Absolutely weird. Absolutely weird. This guy is so image conscious. He uses the most recent street language possible to appear as cool and with it as possible, and he's immersed in Trump land. He's such a normie. He's right in the fight, as if there's anything to be won between Trump, Bibi, and Bondi, Loomer. He cites all these people on his feed. There's just so not anything to do with our theme at all. Like, this guy does not spend time in our world, and I hope he shows up. In fact, I think I'm going to notify him right now too. I'm going to respond. He's been on my feed actually. You guys remember the video I most recently put out, Tale of Two Globies, dealing with the images that they flaunt and say, game over, flurf and stuff. Until you actually,
Red. Are you talking about that one? You talking about
That
Mono
one-
Red?
That's the one I'm talking about. And yeah, I'm just gonna let him know we're on right now, and because he obviously hangs out on Twitter all day looking for meaning in life. So let's.
He's got
give him some.
24/7 right there in his ad.
For sure. He's a party 24/7. So yeah, shouldn't matter that I just tagged him on that. That'll be nice. We'll see if he shows up.
That would definitely make room for him. I would love to see that.
Well, he claims he was here last Friday night and that he, quote, ragdolled the group of you. Do you guys remember that happening at any point?
I
You guys remember getting ragdolled by Globers?
I remember zero ragdolling by Globers in my memory, but I must maybe it happened like before.
Come on back.
You guys, yeah.
So I detect your standard Globy death coming up real soon.
Man, I'm nervous. I just tagged him twice. I just
Stone, you don't know what happened. This guy was a monster. He knew every question, every answer. We couldn't do anything. It was incredible.
Yeah, he made the most well-reasoned globe argument that I ever articulated calmly, and he just listened to all of our points. Yeah, it was crazy. Do you guys remember?
He anticipated your every move, did he?
Did he not only? It's like he knew what we were gonna say before we said it, and he had like a well thought out response to it. And like you could tell that he really internalized our position before he even spoke. It was kind of I wept actually. I wept a fucking
So-
tear.
So he's globy Jesus, is he?
We might
I
have to
mean,
reconsider our
I'm not
position.
trying to say that I was like looking off at the horizon and he was like out at the ocean, like walking on water. I'm not trying to say that, but if there was a man levitating, making good globe arguments, it would not have not been him.
It would have not have been
It
him.
was magical. Now that you mention it, can we have him back, dude? I want to just like bathe in his awesomeness. If we could just come back up here and present those arguments.
I told him I'd be here, man. This is a put up or shut up moment for that guy, you know. So let's find out.
Well, he's definitely got the invite.
Isn't it funny describing that? How you've never heard a Glober do any of those things, make a well-reasoned, calm response to anything.
Dude,
that we
He traveled the
It was
land
sterling.
arguing the globe in parables. It was beautiful.
like
Together
I've only ever
decided-
heard, I've only ever heard fallacious horseshit piled upon other fallacious horseshit, piled upon insults. I actually have heard very few arguments, and only that one well-reasoned, articulated globe argument that we referenced. Just that one time, that one dude came out with it. Other than that, it's been fallacious horseshit as far as I can tell.
Totally.
Probably went on a 40-day logical fallacy fast. That would be magical as well.
Dude, he came out of the desert like Goku comes out of the hyperbolic time chamber. He
A
was
fallacy
He was just
fast.
so
That
well
really pops.
researched and logical. It was insane.
Let's get some ring to it.
Dude, it got so bad that Roman flat earthers had to crucify him. His arguments were too good.
Showing him the way.
And they didn't even want to do it.
Yeah, there was actually another group of flat earthers who was like secretly behind it or whatever.
It was actually against his will. He's not actually a mean guy. Yeah, right.
It was the flat earth.
It was probably the Flat Earth Society that organized it. Everybody knows they're a psyop.
Oh, dude, that's yeah. Well played, Aurelian.
I'm onto something, bro.
The Secret Society of Flat Earth Jesus or whatever. Dang.
The Sedgewits, I think they call them.
I'm dying over here. I'm dying. What's up, Mr. X?
I'm dying.
Yeah. So now that Alan and Shane are here, I'm not gonna lie, I did want to hear some of the end of that smoke that you guys had a 2-day, 48-hour with piezo exchange. But before that, I want to put a button on that. What Ken was talking about, time dilation, man. I 100% agree. I put something in the nest though. Shout out to Shane who liked the original. I clipped it to just to what is talked about with relativistic effects. You hear a lot, and these guys, Shane and Alan, both have done presentations to attest to GPS is being claimed to prove relativity via relativistic effects. If you don't believe in time dilation, then what so have you with the adjustments, quote unquote, adjustments it's made? In the nest, the scaling factor that it's quoted to be used with length contraction and time dilation belongs to us. Yeah, just like other things of meaning, this equation does as well. And shout out to Dialect. He has a matrix theory. Hey, don't throw the baby out with the bathwater, whether you agree or disagree with such. It doesn't negate his accurate scrutinization of the current model. So at your leisure, take a look at that. But if the Aether Cos boys have anything to mention, one question I wanted to ask, the back and forth with what's going on with Franco and Piezo involved, talking about the negation of the mass and how that's crucial to their whole mass attracts mass thing going on, and not having that is pretty much a collapse of their whole theory. In a nutshell, me oversimplifying it. So I just throw two of those points out there, whatever you want to tackle.
Yeah, it's something we've been dealing with for a while. Showing that the mass cancels out in Newtonian dynamics, and it just defers back to kinematics, which means it's not mutually exclusive to anything. It's just based off of a ratio of empirical observation, which just means that they observed how long it took to complete a cycle to return to its original position in the sky, and then they ratio that against pi, and then they're like, oh look, it must be traveling this fast and be the orbital path must be this size based on that ratio of time and periodicity, because all it is, what piezo showed, is how it breaks down really simply to distance over time. That's the equation for velocity. So they're solving for v, so it's literally, when you introduce pi like that, it's just a distance, and then over time is just the time it takes to complete the cycle in seconds. So going over that, what you can do is Kepler's, since it's just distance over time for everything, you can derive different values for big G, because the ratio of periodicity over time is always going to hold, but it's not going to be consistent with the ratio if you try to involve the dynamic aspect of it and try to solve it through that. It's not going to hold. So that's the issue that it's one of the not well talked about issues in physics, but it was that sort of math canceling out relationship is exactly why Michelson-Morley was so important for them, because they really had to get a first order or second order measurement of their expected velocity. Otherwise, they just believed in it.
Dude, I just posted the math that we worked out, which is the Kepler's third law derivation from Newton, where the mass does drop out. And then people were like, no, you need like a bigger mass and a different body when it's rotating, because it doesn't matter when it's the sun, but when it's other matters, like that actual equation, final form has GM in it. And it's like, well, GM actually just reduces to a kinematic observation as well. That's another kinematic observation disguised as dynamics that then just like simplifies out, which is why you can get everything reduced to a periodicity. That's it. If Newton came in and disguised a dynamic force by just copying the same kinematic observation, then it would look exactly like it does right now. Like if there was no reason for there was no dynamic cause of mass attracting mass, it would be able to be removed from the formulas explaining it like it can be right now. And that's something that they used to, I think, explain in like physics for like freshman year physics. But I think Bennett said they haven't done it since his year now. So it's like for the last couple of decades, they seem to not teach that particular derivation for some reason. People on the internet call you stupid and silly when you bring it up, and it's like, no, it used to be well known or whatever.
Do you think the need for that dynamic force contributes to the double speak about, well, gravity is not a force, but you could think of it as a sports, to try to merge the pseudo force into an actual force or something like that?
Dude, I think I love there's differentiation between Newtonian and Einsteinian dynamics, which they used to say that Newtonian dynamics was debunked, now they're replaced by Einsteinian. I think so. When they replaced the meaning of gravity from mass attracting mass to the bending and warping of space-time, you could say that it's fundamentally different, but they are fundamentally different in how they treat the parameter of absolute space, right? Newtonian is dictated by it, needs it all the time. Relativity does away with it completely, and it's the pivotal equivalent. So those are dynamically opposing viewpoints of the same principle, which means they both simultaneously cannot be true. So then you have one definitely debunking and superseding the other. And I think the crazy cope that relativists do is like, well, mass attracting mass was the basis and it works on a local scale. However, in a giant, gravitational system, mass attracting mass creates a gravity well, which then creates the bending and warping of space-time, which creates the non-circular rotation pattern of the non-force acting to create the same effect. And that's nonsense and relativistic gobbledygook, essentially, as Dr. Bennett would say.
It's called the not force.
It's called unfalsifiable trash.
Right. Yep.
Well said, Stone.
And like Mock said, in matters where things cannot be falsified, science is not concerned.
Ooh, did Mock say that? I know Popper said something similar.
I threw it right in my video. Yeah.
Oh, nice.
It's right at the end of my Einstein video. Yeah, for sure, man.
Yeah, it turns out if something's untestable, it's DS, as Bennett would say.
You got it. You got it.
You're saying that math isn't science? I can math it out for you, man. That's not good enough.
I love when Globies say the math proves it. and stuff like that. That's just delightful.
Especially
to
when
hear,
they're
you know?
offering any math or offering anything, they just say "duh math." Like you're stupid because you don't know math, or you know the Earth was a globe.
You can math it out based off of what you want it to be.
Based off of the math, dude.
Based off of the math.
To be fair,
Math-
there's
math
an awful
itself.
lot of abstract spherical coordinate systems around here that people confuse with the globe. To be fair, there's quite a few of them. Many ellipsoid models, geoid models, regular models. You got WGS84. You got regular, lat long. You got people confusing all sorts of shit.
Math in itself, man. What's
Like you said, all sorts of shit.
DS, man?
So I missed you, dude.
Yes, same here, guys. I was still in Vancouver last Friday night, so that was. I wasn't about to attend on my phone. That just would have been crazy. The SIM chip that I bought was from this nowhere little ditzy hole in the wall phone carrier who buys bulk time off the big boys, and they of course get low bandwidth priority with everything that goes up and down through the chip, and it was a null prospect. So yes, glad to be back and sitting in the chair here with my pretty mic.
Nice, dude. I like all the people like that think like they accuse us of word salad. It's like you don't understand, dude. If we're up here saying bullshit and dumb shit, the people up here would call us out, and they would all laugh at us. Like if people, no one just sits and goes, "Oh, I don't understand." Like none of that makes sense. Obviously, everyone else gets it. No, if what we're saying doesn't make sense, we would obviously call each other out. And if it wasn't coherent between us, we'd obviously say notice that too.
Totally. I'm still a little proud. I will say it to have earned my word salad badge, honestly, in debate. I think on this platform, somebody accused me of word salad. It's like, oh, thank you. Thank you for telling me what you have no idea what I'm talking about.
Two things: the semantics the badge and the word salad badge. You got to, if you haven't earned that, you're not discussing things. But
yeah, totally. You're still putting up rookie numbers if you don't have those.
They don't bring up word salad as much anymore.
Nah,
they learned their lesson.
They're like, the lesson was you don't understand words, get a fucking dictionary.
No, that lost its muster when Witsit was around. Then they couldn't do their salad joke. They didn't have the salad dressing on hand or whatever.
Yeah, I remember Globe Globeface grabbing a piece of lettuce mid-debate. Boy, that really had an impact on the outcome, I must say. You know, like,
it was a good argument, I remember, yeah.
That was hilarious. Way to tap out.
You know, I hope Witsit at least capitalized on that and made some salad dressing and made some money off that.
Or T-shirts or something, yeah.
What up, sheepdog?
What up, man? I haven't seen Shane and Alan and Stone in a while, man. I've seen Stone more recently than I've seen Shane and Alan. But what are you all up to on the Celestial Theodolite? Is it like number 365 or something like that?
Number 37 or 38 this week will be, or Monday will be 38, I think.
That's insane, man. Like, I didn't know we had to go over it that much and like take a loss 38 times, man. That's insane. It's self-explanatory.
Dude, you should have seen last week's with Earthly Skeptic going in there. It was just an Oh, you're using globe math, so it's a globe.
Oh, I didn't watch his thing. Did anyone watch his presentation?
You know, I fell asleep when he started doing it.
Damn it. All right, cool. That's fine.
But no. I came at the end and he said, you globers or you flat earthers need to come up with your own math and all this other stuff. You're using our stuff. You can't use it. I'm like, dude, math is math.
Dude, the original parameters from Dr. Mike was to use your stuff to show you how you're wrong. And his thinking was that by using your stuff, you wouldn't quibble about the stuff as your final conclusion is right now. However, his initial premise was that by using the things that you already agreed with, you would therefore more likely agree with the conclusion. And boy, I guess he was wrong about that. That kind of went the other way or whatever.
You mean he they thought they might be reasonable.
Well, yeah, now they're like, no, you used it once. I don't care that it proves us wrong because you referenced it once as a true position. You're automatically wrong. Boom. The other thing is that stupid quibble over you don't have how do you get the distance? How do you get the distance? And we're like, oh, listen, the distance, whether you use Pythagorean theorem, which is for flat approximation, or Haversine, up to 100 miles, the difference is negligible for length. You know what it's not negligible for? Drop over distance, which is what we're geometrically testing for. You can't ignore like 3,000 meters of drop over distance comparison to quibble over like under a meter of length difference between flat and globe. That's retarded. That's retarded. We're showing the giant difference on this model over here. And you're like, no, ignore that elephant. Take a picture of this crack over here where we're trying to compare like unimaginable comparable lengths under a meter. Like that, yeah, let's focus on that difference. Like, who gives a shit? Obviously, you're avoiding the 53 times the occlusion time proves that it's a flat earth, and you're being like, well, actually, because you don't have a separate distance thing, then none of your measurements matter. It's the craziest cop out that I've seen. It's funny that's their most recent position. They're like, after 34 weeks, they're like, no, you know what? We've decided that you can't use distances, therefore you're wrong.
Man, I really liked your idea about asking those 15 questions, though, man. But that guy kept on saying about that Haversine shine, whatever you call it, there, that he couldn't get past that you're using globe tools.
Yeah. So
Yeah,
so the
okay.
radius value, right, is bound to a fictitious observer to linearize it to make it so that, you know, it'll complete the cycle at 60 nautical miles per degree. And if that relationship, you know, can't be tested, then what did Mach say earlier? That if something can't be tested, science need not be concerned with it. So like their whole thing is like so backwards on it. But anyway, if they can use a fictitious observer to linearize the positions of stars so that they can use the change in the position of the stars to define a ground distance, then we can use the same conceptual model. Like, because you're going to derive the same thing based off of the elevation change of the stars. So it's not mutually exclusive. And then so they're like, oh, but you have to put that number radius value into the Haversine formula to calculate it. Well, yeah, it's part of what the coordinate system is based off of, that changes over that specific linearized radius, but it's still bound to a fictitious observer. So it's not mutually exclusive. It's just an abstract coordinate system. Anybody can use it. Like, it's just saying like, that's globe, blah, blah, blah. That's just like rhetoric. It's just empty rhetoric. It's not mutually exclusive globe stuff.
Yep.
Didn't you work out Haversine compensation for 50 clicks with something like 11 inches in terms of the chord?
11 centimeters.
Yeah.
11 centimeters
but,
out of 50,000 meters. Isn't that about right? Yeah, we forgot about that. Oh, our bad.
That's arc and chord, and they're like, you don't get to do that. I'm like, okay, well, we can also do the Pythagorean theorem distance and do the same flat approximation. And no matter which way you approximate it, under 100 kilometers, it turns out it doesn't matter. It's negligible. It can it's under a meter for up to 100 kilometers. So all the distances that we're using for the celestial theodolite, then, thus, fellas, meaning that it doesn't matter. None of the distance differences could possibly matter more than the proportional thousands of feet of missing curvature, which we're directly testing with geometric intersections via elevation angles.
Okay, but hear me out. What if I put latitude and longitude coordinates on an AE map and then draw straight lines on it?
What if I measure distances by steadily radiating outward like an azimuthal equidistant map? And then I know that determining distances is wrong.
I mean, it's weird. It's weird that they can't figure out that it's zero, considering how easily they saw Michelson-Morley as a zero. You know?
It's crazy. But yeah, the backbone of the argument was you don't get to use a distance, and then here's a fake distance that doesn't make any sense because I'm going to misuse spherical coordinates.
Oh, let me strawman you with my stretched out calculation of how distance would be if life was stretched out like an AE map. That's pretty good. That's a pretty effective strawman for someone who doesn't know anything. Like, look how dumb this math looks. And you're like, yeah, boy, if that math had basis in reality, that sure would be stupid. And it's like, well, I look at this math, and oh, that does look neat. I like that one. Oh, but yeah, it has no basis in reality. It turns out, like.
But yeah, you can calculate distances on the ground based off of a ratio of the change of position of the stars in the sky, whether or not the Earth is a globe. It's based off of the same conceptual model. Like this. So
Well, yeah.
The Chinese were geocentric flat earthers. They used the celestial sphere model instead of having a meter. They used a Li. A Li was a ratio of an arc, and it was an arc minute. So they had the same exact situation. So.
But we have Shiva to thank, who absolutely proved using Goon's math that, you can point your iPhone at the sky and you can look at the sun and you can prove that the Earth is round by doing that. Because math, right? Like, thank you, Shiva. That we never could have figured that out.
But I have 4 degrees. Did I mention that?
That's some real cutting edge work.
Hey, you're supposed to I have 4 degrees. When I say stuff, guys,
That's right. That's right.
4 degrees
4.
and invented
4.
email, bro. That's what's up.
I don't. You're talking.
I don't know why he boasts about that. Like, serious. The record is 17. You know that? There's a dude, like a professional student, his entire life, he just went to fucking school, never stopped, and he earned 17 degrees in his lifetime. Like, who gives a shit about 4? What's that even supposed to mean?
Didn't even make it to 20.
That's got to be millions of dollars of education and zero payoff. What kind of person can financially support that?
An extremely rich and senseless one.
Well, guess he gave up. I was going to bring up somebody there. Is it me or something like that?
Oh, yeah, he was way down the bottom with no followers. Is that the guy you're talking about?
Yeah.
Oh, gee, that couldn't possibly be a scrap account from some other idiot. Oh, no, not possible.
But I was going to make sure that we all paid attention real quick so we can get a quick update on him.
Yeah, he's up and down, in and out of the room. He must be having some tech problems, which I can relate to.
It happens. It's totally possible he's not a troll with 0 followers.
Yeah.
No, he just wants to ask a couple of honest questions.
That he made here in February 2026. I don't know. V's following him, so.
He follows everybody.
That means he's been into one of V's spaces. V follows everybody, though. I see you down there, Theseus. I guess Proxy is...
Oh, he's back.
Is he back?
Bottom of the list.
Come on a nature show, and we're like, come on, everything's fine. No one's gonna hurt you. Like, no, there's no predators here, dude. We're all friends.
We're all friendly.
Just come on up here. Everything will be fine here now.
Here, I'm gonna send him a mic, man.
Yeah, FRENS.
Friends.
We could talk about all sorts of the globy stuff, like the lack of gravity, the dynamic cause of mass attracting mass, why things fall, satellite, GPS, interferometry, motion, maps, distances. That's pretty. What do they usually say? Everyone on Facebook usually just says, "Just give me your map." So I don't know. Maybe that's really the only argument that we need.
Man, I want to see them pull out a map that's actually accurate that they believe in. I mean, if you're gonna draw your globe onto a flat map, I can go. But why would you change the shape of continents? I mean, wouldn't Australia just look like Australia on a flat map too? Why's it got to look like a sausage? You get confused when they're drawing it flat.
That's a good sausage argument. I haven't heard that one.
I mean, there's no reason why not to depict the Earth the way it's supposed to be, even if it was a globe and you got to make it flat to travel around, which is weird. Why we don't, depict our reality the way it is and travel that way, but it is what it is.
Well, The argument is that that's because Earth is a sphere, but they're confusing the abstract coordinate system that is lat long with the spherical Earth. So by itself, yes, lat long is a sphere. So everything you're looking at in the sky comports to a spherical coordinate system. But what you have to argue is how that actually relates to the surface of Earth being curved. And the way they say that does that is through a geodetic datum, something like WGS84, which ties through the 0 point of that coordinate system and supposedly starts associating that data with real world points and orthographic heights. So without that, then
He
you don't
came
really
up
have
here,
enough.
man. So it is me.
You're up, buddy. What's happening?
Hiya, Brian. It's Gary.
It's scary. You gotta be fucking kidding me.
No,
How many fucking things do you gotta fucking make?
I can morph as many times as you do.
So, did you have something intelligent to say, Gary?
Yeah, I wanted to ask Shane, what's the speed of the sun around the flat Earth? What's the rotational speed of the sun around flat
Wow,
Earth?
you just don't pay attention at all, do you?
No,
It's
just let
point
Shane
zero.
answer.
I'll give you the answer. It's 0.000.
No, I want Shane to answer.
694
In
RPM.
miles per hour, what is the speed of the sun rotation around the Earth in miles per hour?
Way to misinterpret the model.
No, let Shane answer.
No, I'm not going to answer you, Gary. Are you
Yeah,
drunk
because
right
you
now?
can't.
Because
you
you
can't.
Because you
Are you a little
can't.
bit drunk now, or is this not
Because
yet
you
quite drunk?
can't.
Why can't you answer?
Why don't you know there's an A in can't?
I said can't.
Can't. Listen here,
It
cunt.
sounds like cunt.
No, I said why can't you answer?
That sounds like that's because it's coming from a cunt. Illusion there.
So you're too scared?
Now it's you're too scared. Are you a coward, Shane?
Yeah, why can't you answer?
What are you
It's a simple question.
Are you like
And
12, Gary?
You all know that it blows flat Earth out of the bloody sky.
Are you like 12 years old, man? Like,
How
what's the
fast
deal
do you
with
think the
you?
sun is moving, Gary?
Answer the question.
How fast do you think the sun is moving, Gary?
A typical Brian.
Oh, typical Brian. Ask Gary a question.
No,
The same
ask a
question
stupid
that he asked
question.
us, he can't even answer for himself. How fast?
So, as you say,
How
I
fast
asked
is
the question
the
first.
sun moving
I asked the
in your
question
reality?
first.
How fast is the sun moving in your reality? I bet you I can tell you. You can't.
Shane, how fast is the flat Earth sun
Actually,
rotating around flat Earth in miles per hour?
Well, what we know, right, is
Because
that the
what we know
supposed
is
30 kilometers a second that you think it's moving has never been
no. I want you to answer in
substantiated,
miles
and
per
that's what we
hour
know. is that
Gary,
it
you
is
gotta
on the
shut
definitely-
up if you're gonna
radius.
let him answer, all right?
hey Gary, you asked a question. He's over here answering it. Shut your fucking pie hole.
Is not answering.
You don't know because you can't shut up.
He didn't like the answer, so he just started talking over me. Yeah.
But
He's
I'd like to hear the answer. Go ahead, Shane. Go ahead.
Yeah, you're asking for the speed of the sun around the Earth, but really you're already assuming that the Earth is moving around the sun, and that's why it's funny to ask for the reverse. However,
No, I'm
measurement
not.
motion is 30 kilometers a second, which is the precise thing we've been talking about all night, and how the specific lack of that motion and observation throughout all of history, even though you have interferometry, Michelson-Morley, Michelson-Gale using it to detect the
Just
actual
answer the
rotation,
question.
not detecting this much
Just
bigger
answer the
magnitude.
question.
The current argument is that it can detect axial rotation at 0.4
So you don't
kilometers
know.
a second, but it can't detect 30 kilometers a second, which is the speed you think it's orbiting around the sun. And that's the question at hand: is why can it detect one and not the other if both are happening?
Shane. He wants to
So
know the linear ground speed.
So Shane.
Go ahead, Alan.
Shane owns the.
He wants to know the linear ground speed, Shane.
Yeah.
Like basically just the rotation rate of Earth, they say, relative to the latitude. It would be the
Answer it.
If the Earth is stationary, though, it would just be the same. So it's not going to be like a different speed. If we perceive it through a radius of vision, like its position wise and time is going to be the exact same. Your question's kind of nonsensical.
No, it's not.
Yeah.
So if the Earth is no. So let me.
It's pretty ignorant.
It would be a different time somehow, based off of the same radius of vision.
No. So if the Earth is flat, and I am in a plane, a supersonic plane, and I want to fly all around the circumference of the Earth at the equator, what speed will I be traveling at? So don't deflect anymore. What speed is the sun traveling around?
Dude, these questions are really fucking retarded, dude.
No, they're not. You
Yes,
just can't answer them.
1 second. We already
You just can't answer them. No, you can't. What is it in MPH?
Yo, Gary, 1 second. I got you, dog.
What is it in MPH?
Yo, please stop repeating the question. I'm gonna get it for you. I'm gonna get it for you right now. All right, so linear velocity at the equator. We have, let's see,
1,036.
Yeah.
Wait, that's just the supposed acceleration.
That's what I told you. He wants the linear. He just wants the linear velocity.
So did you say 1,036?
Gary, 1 second.
Something like that. But that comes out to 0.46 kilometers a second. That's why I was saying, hey, how come interferometers can detect that? Because you say that they can. That's how you get, thanks, Bob. And the air's definitely spinning. But they somehow absolutely miss this giant 30 kilometers a second magnitude Earth's orbital velocity that you've already assumed. That's why it's funny. That's what we're looking for.
So 1,036, is that your answer?
No, that's the Globey answer. You just pay attention, Gary.
No, I'm asking for a flat Earth answer.
That's just a GP rate of travel. That's all you were looking for. It's a kinematic argument.
So what's the MPH around flat Earth of the sun?
Like we just told you.
Gary, it would be the same. It's just kinematics.
No, it's not the same.
All right, dude.
That's absolute garbage.
Can you tell us what kinematics is?
No, I want you, all of you, one of you,
hold on a second,
to answer my question, because you can't, can you?
You don't understand the answer, Gary.
We already answered it, but you don't understand the answer.
No, you've not.
And you think it would be a different value somehow.
Why would it be the same?
Because it's based off of the same radius of vision. That's our position.
What's the radius of vision?
It comes out to be 6,731,000 meters.
Oh, right. So that's a lot further than the horizon then.
You see a hemisphere of vision, Gary. That's
I
true.
know.
But
You've told us that we can't see any further than the horizon.
Gary, this isn't a horizon argument. We're talking about positions of celestial bodies in the sky.
No, you're talking about vision.
And you see in a hemisphere of said vision. So
you're talking about vision.
So the object, yes. So the object that you're seeing in the sky and its rate of change, you can derive the same radius value without measuring the ground. So our position is that how we see it angularly over time is an optical effect. You guys are saying that it's a facet of the ground, but the rate of which it moves, 15 degrees per hour, is going to be the same on either model. So it's linear velocity.
So 15 degrees per hour. So that's what you're saying is that the flat Earth sun rotates above flat Earth.
That's what we observe in both models.
So what speed is that above flat Earth?
Well, it would have a latitude
in
MPH.
No, it's nothing to do with latitude.
Gary,
nothing to do with latitude.
Everything in this time.
Gary,
I'm not going to be interrupted mid-sentence.
Knock it off.
If you're at different latitudes, the linear velocity changes, right? Gary?
What's a linear velocity?
Just answer his question, Gary.
No, just answer mine. What's a linear velocity? Because you've not answered my question at all yet. You've just
Gary, sorry to mute you, Alan. Gary, He's in the process of fucking explaining it. Stop asking your question over and over again. This is why you get muted. This is why you get fucking banned from my fucking spaces, because you're just insufferable. If you want to fucking actually ask a question, they all understood your fucking question. They're trying to fucking answer it. Stop interrupting every 3 fucking seconds to ask the same fucking question over and over again. It's getting old, man. Seriously.
Yo,
Sorry, Alan.
asking what the linear velocity is retarded, while asking for the linear velocity at the equator and then acting like changing
Then not
latitudes
knowing
isn't
what
going to
you
give a
got.
different linear velocity. I'm going to go ahead and tap out of this because we've answered your question multiple times on the
No,
linear
you've not.
velocity and how it's been this and how it would be the same.
No, you've not.
And you just keep repeating, no, you haven't, while interrupting and then asking non sequitur questions.
Yeah, I'm done with Gary. Seriously, everybody says I'm mean and shit, but I give motherfuckers way too many chances, and
I
that's what they
personally
fucking
think you're
turn out to
much
be,
too
man.
nice, to be honest. I think you should ban people much quicker, but that's just me. I'm used to Alan, so I could be totally biased. But dude, no one argues that the sky doesn't rotate above the Earth, and if you're saying that that rotation is because of Earth spin, then no measurement you have from the Earth will ever consequently tell you either way, especially within your understanding of relativity and reference frames and relative motion. No observation of relative motion could tell you which one's in motion. So even if you translated that to a ground speed, as you keep saying, linear velocity, that's why I couldn't understand what he was trying to say. Like, what do you mean? What is the linear? What do you want the linear velocity? Oh, the rate at which you think the Earth spins because of the thing you see in the sky. Okay.
If
No,
only
of
his
course.
questions were less ignorantly constructed, we might get somewhere.
Like, so the observation of motion doesn't tell anyone anything, though. That's like a tenet of his belief that he doesn't know he has. Otherwise, I don't think he would make such an argument. Or is that me going too far with it?
Well, Alan said it was an equivalent, a kinematic equivalent. I can't remember what it was about, but then he said, "No, it's not." I'm like, "Do you even know what that means, man?"
No, he has no idea. Difference between an observation of motion that could go either way and then an explanation for the dynamic cause of that motion, which is model dependent. This observation of a motion doesn't go either, especially in relativity, where literally you can't say that shows either way. You have to say it's all relative and all frames are equal. So no observation of relative motion could possibly tell you anything. It's so crazy that they try to say immediately the next sentence, yeah, but like parallax shows we're moving. And stellar aberration totally does too. You're like, what? No, we just went over relativistic frames. Like, come on, man.
And then look, he asked the question. Man, everybody thinks I'm mean. You know, I didn't think his question was all that good, but he asked it. You guys were going to answer it. He wouldn't even let you guys get out 3 words before he started saying, "Nuh-uh, nuh-uh, explain this word." It's like, fucking stop it. That's the most annoying thing ever.
Well, I want someone to talk about the interferometer measurement discrepancy thing, because I know there's an answer. I know the relativistic answer, but nobody that defends it knows that answer. And I just want them to understand the inherent retardedness of saying this super sensitive instrument can measure 0.46 kilometers a second with absolute certainty to show us that Earth is definitely rotating, but it can never measure its orbital velocity at 30 kilometers a second simultaneously. Because suspiciously, whenever we try this particular measurement, Lorentz contraction comes up and contracts the instrument in just the way to make the measurement undetectable. And that's because of relativity, you idiot. And if you don't understand that, then you're stupid.
But we blow all this out of the water by orders of magnitude by only talking about frame of reference as far out as the sun in their model. That if we're talking about a galactic frame of reference or multi-galactic frame of reference, how totally fast the Earth must be going net when you combine all those vectors in terms of any kind of Euclidean measurement, that we would be going so many hundreds of kilometers per second, and you're not seeing any of that in the interferometry here in any context. You know what I mean? Those measurements are just not coming up. It's such a non-issue, and there's so much debate over it. I'm at a loss. You know what I'm saying?
And thank God relativity came along and made sure that no one has to worry about any of that, because it doesn't matter and everything.
Yeah, totally, man. We dilated and contracted it out of the equation. Thanks so much. Thank you for making the math so easy.
And then they want to say everything's fucking kinematics. It could be this or it could be that. We're totally going to go with that fucking process over there. It's like, aren't you then fucking stating that's what it is?
It's been fun arguing with Globers because you got to do so in a way that highlights the inconsistency in their position. Like, you should have some cognitive dissonance by believing these contradictory things. Like with the explanation of people trying to defend Newtonian and Einsteinian gravity at once. Like, no, you can't. We already went over that. But they'll do it in the next breath, no matter what. And then they'll say, no flat earther has never understood this. Like, and in the very next breath, they'll be like, makes this broad statement.
And then they'll post something that says the universal law of gravity. I'm all like, dude.
I like when engineers try to assert that, or actually Globies assert that engineers are using Newtonian all day, every day, because it works.
It's like, oh, dude, you guys using big G every day? No, just the kinematically derived little g. Oh, all right.
Exactly, just the effect. That's what they're using every day.
But speaking of kinematic derivations, I'm going to go grab some spaghetti. I'll be back in a few, lads.
Lift that weight. Right on. Oh, we had a guy in here a second ago, but he's not here anymore. Did anybody remember him? He disappeared.
Yeah.
Gary?
No. A different dude.
Or a real person, maybe.
Yeah, he had an avatar similar to Red Pill down there. I can't remember what exactly it was. Hope he comes back. Maybe he got stage fright.
I had my hand up. Can anybody see my hand up there?
What's up, Methuselah? How you doing?
No, Meth, I don't. But by all means, take the mic. What's up, man? What's up?
I was just going to say, Gary is what he, but you have to say it right. Gary is what he, but you have to say he's a freaking cunt at the end of it, because that's the only thing
you
understand. You got to stick that D in there.
Yes, I agree. The diction is key.
Man, I just don't get how you're going to sit there and ask a question, then just interrupt the whole fucking time that someone's trying to answer it.
Well, I do. That's because I don't really care about your answer, right?
Well, as soon as any words that he doesn't want to hear come out of your mouth, that's when he cuts in.
It's like, you Globies need to understand this, man. You think the world is going on in a whole fucking way. We think a complete opposite. Nothing's gonna fucking line up to it. So stop fucking interrupting.
Dude, however, right, we experience all the same observations.
But we look at everything the fucking same. It all's the same.
When they're like on flat Earth, there would never be nighttime. They would always see the sun. Like, these are the you would be able to see forever. These are the most retarded statements ever. Because no, obviously we've worked into that. We'd be able to see the same. And there's some good math that'll show you, like, a linear loss of visual information at the surface versus a spherical versus a parabolic approximation are all pretty much undetectable. They're all kind of much the same for an observer up to 100 miles. So it's pretty easy to say, observationally from the surface, how they can definitely get away with that. But
yeah, we see the same thing. We just have a non-retarded fucking explanation.
Yeah. Obviously, the sun would never say it's not flat, you idiot. Like, no, we've seen nighttime. Like, we've worked nighttime into our understanding of the world, actually, before we came out here and told you the Earth was flat.
You should be able to see show me a map, dude. You show me a map.
Well, most of them can't even differentiate, an abstract spherical coordinate system from the globe Earth, and that's going to be a key component in understanding the maps argument and why it's, ubiquitous for us, why we can use it as well. If you can't differentiate it, then, you don't really have an argument. You don't really know enough about the subject, in my opinion.
Well, we pinged proxy party 247 like 45 minutes ago, and it's Friday night, and I don't know, man. I see about a 1 in 5 chance at this point that he's just gonna no-show us.
Man,
why don't we have Kat pretend to be a glober, or someone pretend to be like an honest good glober? We'll have fun with that. You got to commit all night or whatever.
I can do it. I can say no repeatedly.
No, be like A good globe. Go Google Earth.
Guys, it's me, Glober Girl 321. Globe for life. Earth radius proves globe. Scott
You have to put on Witsit's globy glasses.
Honestly, you guys could all be better globers than the ones we get subjected to.
Nuh-uh.
Whoa, well, you're right. You convinced me.
Yeah, I was overwhelmed by that rebuttal right there. That was crazy.
I mean, seriously, how can you just say
sunset? GG noobs.
How can you just say gravity to everything? It's gravity.
Dude, you know that you need gravity to have buoyancy, you need to have density, you need to do it. Everything's gravity. And it's like, nah, man, that's just little g, which is like, look, kinematic, h equals 1/2 a times t squared plus vt, but then you do some simplification, and it's just little a equals 2h over t squared, which is just, the height you drop it from, time takes to fall, and that's little g. And you're like, oh my God, it comes out to 9.8. We own that. And it's like, no. Again, you're not differentiating kinematics and dynamics. Kinematics would be this little g, this measurement, this observed motion. No one disputes that things fall at this measurable rate. We only dispute why things fall at the measurable rate. And that's where they get into big G, which is dynamics, which is what we thoroughly dispute as well, which, when used in conjunction with the formulas in space and approximations, it gets approximated out as an empirical observation as a constant anyway.
Dude, I can't remember who it was, man, but they said, I said, then why is the balloon floating up? And the guy goes, it's due to gravity. So gravity's pulling it down and pushing things up? Man. What's that balloon being attracted to? What's up there? Is it going to the moon?
Yeah, but okay, but explain sunsets.
Explain sunset. Man, Hap owes me $500. He said, you guys can't explain sunsets for like the millionth time, so I freaking explained it again and gave him a video showing the fucking sun going psh, and just vanishing. And you know what he came back with? He said, nope, that's because the earth is spinning backwards. I was like, you fucking motherfucker. You owe me $500, Hap.
You might be one of the worst globers, like the most insufferable online posters, the time wasters who would just copy and paste the same stuff over and over again and waste your time. Like one of the worst, I gotta say.
One of the worst. I mean, seriously, you can say you don't like it or he tried and he sounds stupid. I just disagree with it. Whatever. But don't say it wasn't explained to you.
Dude, I like to block people who don't deserve it. Like, so, but my motto is like, if people who regularly challenge, I think you find on Twitter, if you offer good arguments and if you're not fallacious, if you do like good arguments, I generally just interact with you constantly and don't block you, right? I'm not going to block people who offer good arguments. I like to be challenged. Who I block are retards who offer no challenge and recite slogans and do nothing and don't understand the argument and just say the most unrelated stupid thing. And I think there's a good meme I saw that was like, being removed from intelligent conversation and bragging about it, which is what you do when you get blocked by one of us. Like, haha, I win. He blocked me. I made such good arguments. It's like cheering after getting kicked out of a restaurant for shitting on the floor. And I thought that was the funniest comparison that I've heard for why I block people and why I don't care that they, then take a victory lap about it or whatever.
Mm-hmm.
It sums it up perfectly.
Yeah, I thought that was pretty good.
You can't explain sunsets. Seriously, Hap? You're going to ask that? Seriously.
No, it ain't no worse than any of the shit I get from other people. I was discussing terrestrial refraction and how they have to use that for like Pete Gaspard, right? They want to invoke terrestrial refraction. So I just asked them, I said, okay, so you say it's terrestrial refraction. Give me the equation so that I can predict how far I'll see. And because what you're doing is a post-diction. Oh, it's not a post-diction. We can totally predict it. Okay, well, just show me, so I can see it. Well, I'd give it to you, but you don't know math, so I'd just be wasting my time.
What I'd like to see from the Globies claiming anything about the peak gas part, like exactly what you were talking about, Ken. I'd just like to see them take the real world variables of that climate, that condition, at that point, at the time the picture was taken, and show us the formula that you're going to put it in that's going to predict that amount of terrestrial refraction. Let's see the actual hard figures based on that example with those physical dynamics in play. And is that really going to come to it using the formula we're all supposedly learned in university or not? And how close are we? What percentage of it are we actually supposed to expect to see? And what are you claiming we're seeing? And you'll find those two figures are nowhere near. Those two figures are going to be several orders of magnitude in difference.
Yeah, maybe I should use that. Use peak gas part and just tell them, okay, just show me the math.
Yeah, produce the real world figures for those conditions at that time of day, that day of the year. And, you know, this is the typical of what you expect for a lapse rate between here and there on those particular points between here and there. And okay, let's work that out section by section, lapse rate by lapse rate, you know, vertical by vertical between you and the target. And let's just see how much terrestrial refraction is predicted by the math, by the formula that is accepted by all of science because it's thoroughly tested. You know what I mean? Plug those in there, and hey, buddy, let's see what that actually comes out as. How much terrestrial refraction are we actually talking about here with those conditions? And game's over, right there.
Well, I do think that they only use it as post-diction most of the time. I think they're like, "Oh yeah, you made an observation. I'll show you how dumb you are." Where was it? How far was it? How high was the observer? Okay. Okay. This is how much refraction there was, dummy. And it's like, well, no, that's a backwards compatible refraction constant.
Yes.
You're just adjusting a slider to get back to where it was until you add enough refraction to make anything work. That's just math.
Yes. That's
like,
very Jesse and Rue. Yes,
Yep.
Indeed.
I was gonna say because then Ruhev says, don't argue about it on the surface because there could theoretically to them under like whatever if it be an infinite amount of refraction. So if I argue that you can actually look bend over and see your own ass if with enough refraction, if I adjust that constant enough, like you can, it can bend that arc infinitely and they'll just go and it's like yeah, they'll agree with that and you're like what? Oh, you don't give a shit. Like, oh, you will just argue this to, oh, I'll do. You know what? I'll never discuss a ground-based observation with you ever again. That's cool. I mean, like, thank you for telling me. Like, that's why I respect Ruhev, dude, because he told me that straight up, and I was like, oh, then I'll never, like, oh, there's no need for us to ever talk about that. We can talk about other shit. Like that would be silly of me.
Well, he told me that as long as it's at 1,000 feet or above, it's standard refraction only, 7/6R.
So 7/6R, yes, but then everything becomes disproven because you need to adjust it for every observation that doesn't agree with that. There's no way.
And what about the opacity of air? Does that ever get talked about when you're using 7/6R? I mean, like, sure, yeah, you could just bend over and see your own ass if only there wasn't a shit ton of atmosphere in the way.
Well, so what about infrared observations? Infrared, if you're going to use 7/6R at 1,000 feet, I would love to see some infrared footage showing you that 7/6R explains anything you'd record with infrared at 1,000 feet, to be honest. I think someone we know is doing that soon, so that should be fun.
Oh, can't wait.
And for infrared, obviously has, much less, like, if you're going to blame refraction, you can't really do it with infrared. That's why it's super interesting to use that as an optical observation, I think.
Somebody does that infrared. They've got one like 150 miles.
You talk about JT Tolan?
Yeah.
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 Questionable on some of his previous observations, quote, but sometimes he does hit it right on the head.
At 150 miles, do you think 7/6R would explain it, Ken, without doing any math or looking at it any further? Off the dome.
No.
Yeah.
Got Piezo up in the house.
Yeah, I saw him sneak in there.
Always being a creep, though. He's just listening.
What's up, guys?
There he is. What up, man?
I just heard someone say that we can't explain sunsets, but I wonder if they've ever considered the simple geometry of a sphere of light moving over a disk and how the contour of the sphere raises up as it sweeps away from the ground. So it actually, like, if you trace that arc away from the ground, as you increase in elevation at the same point on the ground, you could be in the light. Whereas as you go lower, you wouldn't be in the light because the arc of light sweeps up. So that's why at a higher elevation at the same ground position, you can have sunlight because you're at the edge of where the sphere of light reaches. Actually, really simple geometrically. It's weird that they still say stuff like that.
And that they can't see that there's a gradient in the density of the air on the way up the hill. So obviously the sunlight hitting you at the top of the hill is going through literally less matter and can go farther and get to you.
Hi, this is Globe Girl 3122. I have a question for Piezo, who thinks a sunset on a flat Earth is a possibility.
What did you just say?
Have you
Kind of low there.
Have you considered that the moon and sun turn upside down when you change latitudes? That's impossible on a flat Earth.
Oh, you mean like you go to the opposite side of the thing in your room on the ceiling, and now the smiley face is upside down?
That only applies to ceilings. It can't apply to the sky. Wow, you have to lie to Flurf.
That you, Hap?
Is that you, Goon?
Dude, I heard that that's Jesse wants to challenge people to a Battle of the Beams debate because he said he already debunked it apparently. Somehow I missed that.
Yeah, he totally debunked that a long time ago. He all he had to do was take a look at the figures and he fudged them. He fudged them here and fudged them hard, and the next thing you know, he had proved it. It was just totally debunked.
I'm sure we're talking about Jesse Path of Light right now, right?
Dude, I forgot that when you put out a challenge that Jesse would immediately use that as a way to worm in and just get more interaction with us somehow and try to
Totally.
I should have known that immediately. I didn't. That's on me.
I guess we'll have to brew up a few more memes. I don't know, man.
Well, it's been a year and a half. It's been 18 months, right? So it's like that's the point where it has to be revisited. You know, if a topic goes dry after not being debunked for 18 months, you have to throw it back in the face. So,
well, I think it just comes down to the celestial theodolites kicking his ass. So he needs to find something else.
Have you considered that as a general sophist expert, it doesn't really matter what subject it is as long as he's the one talking about it as like the general goal?
I don't think it extends just to theodolites. I think he has an appliance fetish.
I don't want to talk about him anymore. I was just saying that's a thing. I don't want to talk about Jesse for any more time if we can.
That's a very good argument. Anyway, what up? What else is up, Piezo?
Oh well, I kind of figured out how electrons actually work and what the wave function of the Schrodinger equation actually represents in like 3D space. So you know, the whole wave particle duality being gay and electrons are actually waves, you know, but like how are they waves and what way are they waves, right? So like think about this, right? If you got a hydrogen atom, it's just one electron and one proton. So one might ask oneself, well, hey, if we believe in the particle theory, right? We've got a proton in the middle and an electron whose position we don't know that's just whizzing around this proton. Why does it always remain at a fixed distance? You know, and you'll get some like absolute, you know, retard pseudoscience speak from the you know hallucinating chat robot. Principle of not being able to measure it any further, as if like
is it me or is it
reason,
Piezo
but
rebutting?
actually I discovered.
Yeah, you're kind of roboting a little bit there, Piezo.
Okay, it's not me. Good.
My bad. I passed through a little a little dead spot, kind of. I think you should be able to hear me in just a second. Am I good now?
Yeah, you're solid.
I'm good there.
Yep.
All right. So imagine you're looking at a top-down view. Okay, the top-down view of an atom. You just got like a little electron in the middle, or sorry, a proton in the middle. It's a little ball, and then you draw a big circle around it. That circle represents the ground state, the lowest energy level of an electron. Instead of putting another little dot on that circle, instead you draw a sine wave running back and forth from the proton in the middle to the edge of the circle outside, and it just wraps around the inside. If you draw this all the way around, it might end up looking somewhat like a flower petal. Okay. Now imagine this flower petal. You can think of it like a fan blade as well, like a top-down view of a fan blade. The fan blade part is where the energy of the electron is spread out over space. And the empty space around it is where there is no electron. So this thing is spinning around at really, really, really fast rates. So imagine you got a fan blade spinning super fast. If an object is trying to fly into the atom and touch the atom, right? Odds are it's going to get hit at the outside of that circle, right? There's a very high chance it's going to.
Lost you again, man. Very high chance.
Yep.
Oh,
There goes that Adam.
We lost all of his electrons.
he just flew out of that orbit, and that was that.
Dang it. Maybe I'll try this again when I get back to my PC or something. Frustrating.
But satellites.
We
Oh,
love
yeah,
them.
dude. The GM equals B squared R, bro. They're like, all these objects going around the sun seem like they have the same GM. I'm like, yeah. They're like, all the objects moving around the Earth have their own GM. I'm like, yeah. They're like, okay, so that means it's the mass. I'm like, no. Where did you get mass? You think you can, drop objects and they fall to the ground and suddenly that means you can weigh the planets?
Yes, precisely.
Dude, that's what cracks me up is how are they even deciding how much a planet weighs, man?
By plugging in for an assumed mass in an equation where they think that they got a big G value by measuring the effects of little lead balls pulling on each other. Or actually a big lead ball pulling on a small lead ball.
From the very equation where we derive the mass, and when we equate gravitational to centripetal force and the mass drops out from that very equation, actually, that's what they claim.
Sounds very scientific-y.
Yeah, I want to smoke whatever Cavendish was smoking when he come up with that.
It turns out it's just algebra. They just swap out a variable and they just rearrange it rather and solve for the missing thing. So they're like, oh, it must be this amount. But remember, the whole thing was derived off of periodicities. So, they're starting off with like a proportional ratio and then just using that as like the fixed amount to start off with. But yeah, once they have that, they can just shuffle the terms around and then solve for the missing one.
Is it just me? Mike?
Yeah, he's coming in pretty quiet there.
Nobody can hear me. It's okay.
And somebody's mics are too close together.
Yeah, I think it was a combination of me talking softly too. Can you hear me now?
Yeah,
halfway.
Nice. All right, well, I'll be back on the computer in a minute.
I think it's because your mic was open too. Yeah.
No, it sounds like you're talking to your phone from like a mile away. But he was saying it's just an algebraic transform. Like you just move the m around and you solve for m instead of solving for like all the other variables. You plug in what you know. That's how they get mass. So that's how you use a fabricated equation to weigh planets, right? That's pretty funny. The equation that actually you can, drop the mass right out because it just becomes a periodicity in an empirical observation. That's the same equation that they use to actually weigh the planet. So they definitely know how much planets weigh because of an arbitrary m that they inserted that actually comes right out when you use it in practicality.
Not very succinctly put, but totally exactly correct.
And then they came up with the Earth weighing 6.6 septillion tons, man. Sextillion.
That's marketing.
You can't prove otherwise. You can't prove it's not that.
Starting to sound like Hap.
You can't prove that you can't get gas in a vacuum chamber and watch it light on fire, turn it into a ball and light on fire. You can't prove you can't do that. I wish these globies would scrutinize their own model as much as they try to scrutinize us.
Well, maybe they should come in here and we can help them with it. I'm good with scrutiny.
Scrutinize. They don't scrutinize us. They just outright reject everything we say, and everything that we say is automatically wrong, no matter what we say, just because of the fact that we said it. And obviously, we're flat earthers, so therefore we can't possibly be right about anything. That's the framework for which they operate, and it's the only thing that explains their ridiculous behavior.
Nuh-uh.
Oh yeah, well here's a paper. Like, hey, no flat earther has ever given me a paper saying that there's no motion. Oh well, here's a paper showing C plus V. I don't have time to read that. I'm not gonna read that. That's stupid. That's cherry picking. Stupid flirt-dumb. Doesn't matter. Doesn't matter. Not science. Pseudoscientific quackery. Doesn't matter. Doesn't matter.
What's that peer reviewed?
Then the next sentence. No flat earther has ever given me any evidence that this is Earth. It's like the craziest little dance.
Show me all the scientists that say the Earth is flat. The ones that believe in special relativity? All right.
Show me a peer-reviewed paper that agrees with me.
Yeah, that cracks me up. I mean, I don't totally discount the peer review method, but to hang your hat on it and say if it's not peer reviewed, I can't look at it, it's a ridiculous notion.
Well, if we at Ether Cause opened up a peer review and only 3 of us could participate and we disavowed all papers that didn't certify there was in fact an ether drift and a wind measurement, then we would have the same sort of echo chamber publication of only ether supporting papers and be like, show me a paper that I previously approved that disagrees with me. Or else.
Totally. And we can totally call ourselves referees too.
Exactly. We don't agree. You're wrong. You're wrong.
Such a fucking, they're always like, "Where's your peer review paper?"
You should mute up there, Cat.
Yeah,
some fine feedback.
Yeah, there's some wicked feedback.
Yeah, I can hear, like, Alan, it's a faint echo, but it's kind of funny. I can hear half of it. I want to laugh, but I didn't hear enough of it to quite laugh.
I'm sending him back to the computer.
Yeah.
All done with that big fat bag.
See, you came in just fine. A little low, but pretty good.
So we should start the peer review process, dude, so we can certify some ether papers. Be like, listen, well, we all came to the same conclusion when we read this paper. So therefore, if your conclusion is different, you're wrong. Like, it sounds silly, but that's how Wikipedia works, right? That's how they're telling us, well, actually, Mickelson and Morley were looking for the ether and they found nothing. Oh, well, not according to their paper, the preface, the math they used, or the conclusion. What are you looking at? Oh, just Wikipedia. Okay. So unless what I say agrees with what you're looking at Wikipedia, I'm lying. And they're like, yeah, and then 90% of them will take that position.
If you want to expect to see anything you upload or correct on Wikipedia to be seen 15 minutes or more after you put it actually up there, you're going to have to exercise some guerrilla bot tactics to constantly re-update it every time they delete it. You know what I mean? It's bot versus bot information war kind of thing on wikis, believe it or not.
No, they have a very firm grip of what gets published there and what stays there. Absolutely.
Totally.
Which is why it's like, this is funny that this is the most lied about experimental evidence. Like, if you ask AI or go to Wikipedia and ask them about interferometry, it will get all confused and doublespeak and lie to your face about what it can and can't do and what it's supposed to do. And if you you understand the history, it's like, oh, but it can do this, but it can't do that. What? Relativistic? What? Like, what are you talking about?
An AI will lie about any topic.
Yeah, yeah.
Not just this.
It's literally designed to like please you and give you what you want. It also does a simultaneous site profile on the way you're asking and how you're asking it to determine your tone, and then to determine a reciprocal tone in which it thinks you would most like it to respond to you in, and does that constantly on like 3 to 4 levels. It's it is pretty crazy.
Yes, while constantly stroking your ego, and every time you catch it deceiving you, it's like, oh boy, you totally are smarter than everybody else, dude. Okay, my bad. Now I'm gonna be honest for sure. For cereal from here on out. No, it's all good now, bro, because you're fucking brilliant. How dare I even try to lie against somebody so fucking sly like you, dude? Please continue.
So I want to point out that we got Proxy down there in the listener section.
Oh shit, we do? Did show? He did show. Well, fire it up, man.
I sent him an invite. We got Jonathan down there too, man. He's a reasonable Globie.
Yo, Jonathan, did you get a chance to read those papers regarding astronomical refraction and the derivation thereof?
Come on up, Jonathan.
Okay, you asked him a direct question and then waited, so that puts a little bit of pressure on him to come up here and answer for himself. The sly.
It looks like Proxy left. Oh, did he come up here and get her speaker?
No,
I show him.
got a speaker.
He's right there. Yep, he's right there.
Yeah, he's a speaker.
What's up, y'all?
So people are saying you ragdollist or something, man.
that was y'all's own quote. I found it hilarious. I remember there's what is it? Dog walking is what they call it on TikTok, but ragdolling is even better. Ragdolled them, but yeah, my mind is open. I'm wondering if y'all have devised any experiments that might help demonstrate your hypothesis.
Which one?
That the Earth is either not moving or standing still or a flat plane.
A flat plane.
Okay, did you not watch any of the conference in November?
I did not.
Oh, wow.
Go ahead and fill me in.
Have you watched any of my videos on Rumble or BitChute?
No, what's the most compelling point you got?
Wow. You're really coming in that unprepared? You know nothing about me?
I'm raw dogging this debate. Yeah, totally raw dogging it.
Okay, well then we're
make
not
it
going to
easier
be
for you,
leading the
right?
show here. We're actually going to make it easier for you. We'll start you off with the first question. And it's a classic. Do you have any evidence exclusively, mutually exclusive to the globe that proves any of your heliocentric theorem?
Yeah, sure. I call my friend in Europe right now, or China, and have them send, I guess, a photograph of the sun. Would work for y'all, right?
No, that wouldn't do it. Not by a long shot. Are you familiar?
Why would that be exclusive proof of
Are you familiar with the term? Oh shit! Now it just blew right past me. Kinematic equivalent.
No. What's a pneumatic equivalent?
Okay. Well, you see, you have to know the difference between kinematics and dynamics. Are you up on that much?
Nope.
Okay, the kinematics of a situation in analysis are all about the measurement of it.
Right.
The dynamics are the cause for it.
Okay.
Okay.
Makes sense.
Great. So that's what we're looking for from you. And when you talk about something that's going by in the sky with some kind of periodicity, that's kinematics. That's just something you're measuring, something going by.
Right.
That's not dynamics. That speaks not anything to cause. So I think you're
Right.
going to have to do a little better.
Okay, so you want more of the cause, like why is the light or the sun?
No, no,
in,
no. It has
visible in
nothing to do
China
with
and not in
about
America?
why. This has to do with something that you're saying here is evidence that is mutually exclusive to prove only that you live on a globe and not, and that cannot also be, workable, doable on a flat Earth model. Do you have
How about
anything that's
lasers?
mutually exclusive? What about lasers?
You take a very powerful laser and I point it at China, and we'll be able to see it. Like a laser powerful enough to see, from the naked eye, right? We got those now, and that would be a really easy experiment, right?
Well, why aren't they doing it every day? No, just kidding. No, it's about this thing called the opacity value of air.
Oh, I was wondering about that. What is the opacity value of air when it comes to like lasers?
Well, you can actually compute it even when some comes to do with something like the sun in your own model, allegedly. But no, that's really not what's at issue though here, is it? We're talking about something where you can attribute
Well,
cause.
it is a very
right?
important metric to have established.
Which?
The opacity of air, the translucence of our atmosphere.
But how is that significant to the cause of something? And then saying mutually exclusive, this is because we live on a globe, we experience X, that we have evidence X, and this is really what we're looking for. We're not looking to quantify something about the air.
Well, because it would disprove your point.
No, we observe it to be true, and look, man, any horizontal measurement of light of any brightness getting farther away from you eventually is not bright enough to see.
Unless you're in a vacuum.
Well, yeah, but we're not, are we?
Nope. But the moon is.
It is?
Yep.
Oh, that's
more or
interesting. More or less.
Yeah.
Which is it?
It's close to a vacuum. There being no gas particles. There are gas particles in space, but they are closer to vacuum than our atmosphere, at least.
Wow.
Close enough to be.
So we're just going to
more or less a
around.
vacuum at the scale. You know what I mean?
Okay. So you can't give me a value?
It depends on where you're at in space.
Oh, well, what does it get down to in terms of pressure?
There are vacuums within space. I mean, there are pockets of vacuum within space for sure.
For sure, dude. Because we went out there and measured it, right?
Well, that's how gravity works.
Whoa,
yeah.
Whoa. Wait a minute.
What?
We're not talking about gravity. We're are you just going to scattergun all night? Is that how we're going to run this? With absolutely nothing quantified
I'm more than happy to focus on the atmospheric opacity if you want. We'll establish that first.
Well, we were just in the middle of talking about vacuum out in space, and that for sure it's something, but you don't even know what the value might be.
If you're having a hard time staying focused, then let's go back to the opacity of our atmosphere.
I'm telling you, that's not relevant to what we were even talking about. I did point that out.
I know you're saying that, but I'm disagreeing. I think it's entirely relevant.
No, you want to quantify a particular rate of density, a rate of decay in terms of light absorption, when really all that is necessary is to observe the phenomenon as real, that it does actually happen, right? You want to quantify the gradient, and I'm saying it happens, okay?
Yeah, when you ignore variables, things become confusing, right?
All I had to do was check order of magnitude, guy, because, like I said, for example, a headlight, so many feet or tens, hundreds, thousands of feet away, you simply cannot have a headlight anymore. Okay, so you scale up as you see fit, but because it's a...
Guys, is the audio coming in broken for you, or is it just me? Do I need to do something?
That's all you got. I mean, all these people are watching to see what you can have to
Stone.
Okay, it's not.
Oh man.
But
Yep.
this so I'm not really sure how this is.
All on here.
I
So
know that
far,
like
he
your
doesn't
I'm seeing it.
understand kinematics or dynamics. He
I
doesn't
know that
understand
your visual
atmospheric
acuity,
capacity.
your vision has the range of about 200 to 300 miles, depending on how clear the atmosphere is. When it comes to like reading a sign or seeing a thing, right?
You do realize that being able to see 300 miles would be impossible on a globe with a radius of 3,959 miles, right?
Exactly, which is why it's a little
Exactly.
tougher to
What?
see.
What do you mean
Right.
exactly?
No, that would be true if you put your eyeball straight on the ground and like flat on the ground and just looked out towards the horizon. You'd probably have, less than a 300-foot view.
No, 3 miles comes out to be exactly geometrically on a globe.
You could
Maybe I'm getting it wrong. Maybe it's like 300 miles, not 300 feet. That's probably more right. Yeah, I got my metrics wrong. My bad. It's miles, not feet.
You wouldn't be able to see 300 miles at
No,
all.
it's 3 miles for a 6-foot observer on the surface of Earth using the radius 3959 and Pythagorean theorem, including your observer height. Comes out to like 1.22 times the square root of the observer's height in feet, which you plug in 6 feet, ends up being about 3 miles. That's how that works. I don't know what you're talking about.
Okay, so yeah, like if we were on the ocean and we were to look out about 3 miles, that's about your range. Yeah.
No, like geometrically on the surface of a sphere anywhere.
Yeah, but Earth is not a perfect sphere. Earth is a bumpy sphere. So if you were to go out in the water and go out about 3 miles, you start to see the beach disappear, right?
It's not different on a beach than it is on the. You're arguing over a geoidal difference of an ellipsoid model, which is the non-perfect sphere, ellipsoid flattening at the equator. Difference between a perfectly symmetrical sphere and it's an imperceptible difference even on the surface. So that's retarded.
I would argue that mountains are perceptible.
Yep,
Mountains,
topography
you
is
say?
real.
Yeah, elevation is something you can perceive.
Sure.
So, using your perspective on top of a mountain or an elevation, or anywhere else in the world that has like a dip or some movement in the crust, you're going to have variation, and that's going to either allow you to see further or shorter, depending on where you're at, right?
Increasing observer height in either model increases the distance you can see. That equation for distance, how you can see on the sphere, increases with observer height as we started. So the Pythagorean theorem remains the same. Distance to the center of the sphere remains the same. Observer height changes. If you want to add 300 miles to that, that will change the observer height, and it works for either model. On the flat Earth, if you go higher, you can see further. That's just an effective perspective. To not think that would be the case seems silly.
Right.
You do realize that at a 6-foot observer height, 300 miles would have like 58,742 feet of Earth curvature to deal with, right?
How many miles?
Vertical drop, 58,000 feet. As
It's
you
11,
go,
it's
look towards the horizon.
11.1 miles. You'd be looking into space. You wouldn't be looking at the Earth. You do realize that. You can grasp that, yes?
No, I don't understand what you're saying at all.
You're on a ball, right?
Right.
Well, from your point out 300 miles, that 300 miles should be below your feet, correct?
Yes, right.
Yes. So how could you think you're seeing 300 miles? You'd be staring out into space.
Exactly what happens, yeah.
No, it doesn't. You just said it doesn't. You said you can see 300 miles.
Well, through the atmosphere. You can see 300 miles through the atmosphere before your vision is obscured by the atmosphere itself, right?
300 miles away, you have 11 miles of curvature drop.
Okay.
You wouldn't be able to see that because you think your eyesight curves around the ball?
Nope.
Then your eyesight goes straight out?
My eyesight is pretty straight. like a
Yeah,
laser.
so if you're standing there and you're looking 3 miles in a direction, you're looking straight, you'd be looking into space because you just said your eyes doesn't curve around a fucking ball.
Exactly, because we live on a
Exactly
ball.
what?
I mean, that's how
What is your
living on the
argument?
ball works, man. I don't know what to tell you.
What is your
Well, that's how
argument
living on a
precisely
flat
at this
plane
point?
works.
It sounds like you're agreeing with me here.
No, he's trying to tell you that we've got observations of like Peak Gaspard, 275 miles. We can see Peak Gaspard, entire mountain, not the top of it, not a little tip or a little hint of it. We can literally see Peak Gaspard from 275 miles away.
Yeah, it makes sense.
Oh, does it?
No, it
Yep.
doesn't at all.
Because we're able to see, we have at least a 300-mile range with our vision within our atmosphere, right?
Yeah, when it's supposed to be way below
On a clear
your
day.
eyesight. It's supposed you believe that you should be able to look around the curve and see the mountain.
It's not what I
miles
believe.
below you.
Nope.
Well, I mean, that's what you're saying. Oh, it makes sense. We can see it.
You wouldn't be able to see it if it was miles below you.
Well, 275 miles away puts it miles below you. And yet
11.
we have a world record. We have a world record photograph of Peak Gaspard, 275 miles away. You know what it looks like? It looks like it's straight across a flat plane. Doesn't look like it's around the curve of a ball miles down below your
Probably because
eyesight.
it is on a big flat plane, right?
Well, welcome to flat Earth.
Well, it's a flat part of Earth, my dude.
What?
Yeah, right.
Golf ball.
How many
Earth?
flat sections of Earth do you need to make a ball?
Well, it wouldn't be a perfect ball, but it would be ball shaped.
Well, it's imperceptibly an imperfect ball. You can't look at it and tell that it's not perfect.
I can though.
Oh, you can.
Yeah.
I can tell my geoidal horizon from my rail horizon, bro. Dude, I can deflect the vertical right from my eyesight. When I see that mountain, I'm doing my astro-geodetic deflection, aligning my geodetic latitude with my astronomical latitude from the bridge of my nose, son. What have you been doing?
And
Science.
this conversation was
I've
going
been
nowhere when
I've
he
been
didn't
observing
realize.
repeatedly observable reality, right? That's what I've been doing.
What kind of science have you been doing?
What do you think I just said?
Well, I hypothesized that autism was actually a superpower, and I kind of had that hypothesis verified through ChatGPT the other day. It's pretty interesting.
No, I mean relative to science. What did you actually, do?
I taught aquatic science camp at Texas State.
Aquatic science camp.
Yeah.
And how old were the people in the class?
Oh, they're like teenagers.
Uh-huh. Okay.
Aquatic science class. What is that? Is that like swim instructor?
Yeah, taxonomy, stuff like that. Scuba diving.
I knew this conversation was going nowhere when he didn't know what mutually exclusive was.
I think I can understand what mutually exclusive is.
This is pretty sad, dude. You were talking a lot of shit this week, and I really am not seeing any substance from you whatsoever. We talk about
That
this
might make
stuff
you
every
feel
week.
better,
For months on end, we are here on Friday nights, but you think you're going to show up with absolutely nothing in your pocket. No background, no research, no digging, no homework, nothing, no preparation at all. And you think are you on top of this conversation, do you think, right now? How do you think you're doing right now?
I feel pretty good. Are you okay?
See, now that's ego and denial working really hard against you. You need to take a much closer look at what's going on here, man, because to the rest of us who are totally fluent in this topic, you look like an absolute clown.
Well, I'm comfortable with that. I'm perfectly okay with that. Now, if we can go back to refuting my point and just talking about the cold, hard, repeatably observable reality of the situation, that'd be great.
Oh, wow. Okay.
You okay?
Oh, sure. I was
Hey,
just trying to make a choice of what path I would.
You were
bring
trying to
on.
make an ad hominem and it fell flat, dude. Like
No,
honestly,
No, there was no ad
your
hominem
roast.
there.
it's another
I
thing
That
didn't
was a
you don't
self
dispute or
roast.
disprove anything
That
you
was
said.
a self roast, dude.
No, dude, I did not insult you in order to try to disprove anything you
No,
said.
you
because
tried to insult
you
me
haven't
and it worked.
said
It didn't
anything.
work. You tried to insult me and it did not work. It fell flat on its. It fell flat on its face.
So
Okay,
let me
since
ask you a
you
question. Let me ask you
okay,
a
go ahead.
question there, Proxy.
Go ahead.
Can you tell me where the horizon would be at a 6-foot observer height?
Yeah, I can run the math for you real quick. Let's find out. Is it about 3 miles?
It is about 3 miles. Can you tell me what the horizon is?
The horizon is the place, the furthest point you can see with your naked eye, right? So are we going with that?
You tell me, man. I asked the question.
All right, let's put it this way: the
That's
horizon
actually incorrect.
is the boundary between two different things in space,
Swing and a miss, kiddo.
or like the let's see, how do you
See,
define a horizon?
Think about
Horizon
it.
would
Come on, you're
be
almost there.
the
Think about it.
visual edge. The visual edge of something is what the
It
horizon would be, right?
is optical. You're on the right track. Keep going down optical.
So horizon is the visible edge of something
is
in
it supposed
space.
to be? Is it supposed to be where your physical curvature's at?
Well, yeah,
Well, then why didn't you say that?
because it depends on what you're looking at. Like if you're looking at a ball, it's going to have curvature to the horizon. But if you're looking at like a giant cube, it's going to have straight angles on the horizon.
I'm asking you what you think the horizon is. So obviously, I'm talking about the paradigm you live in.
Well, even the
Okay.
definition.
Well, it's still the observable edge of a thing in space.
No.
Have you not Googled
You want to help? You want to help me with what a horizon is?
Where the sky meets the ground.
The apparent place where the sky meets the ground, dude. It's so easy. You're almost there. You're
That's
like, it's an
that's
object, apparent.
that's a
Furthest you can
redneck way of
see.
saying it. Sure, yeah.
No, that's the actual
Redneck?
definition.
Now that's an ad
of the
hom.
word. Like if you Googled horizon right now, that's what you would find as the definition for the word. That's why we all said it at the same time, because before we started, we all Googled what the word meant and we looked at the definition and then we formed our opinion on it. We didn't just start slinging from the hip to what we think we meant to use it in context, which I thought was pretty funny and admirable.
Right.
I admire the confidence.
Way to whip out that ad
the
hom.
horizon
Proxy. So to follow up on my question here, if you're not even really sure what the horizon is, do you think you're well adept at this conversation?
I'll put it to you this way: if you can't debate me, I don't think you're going to do any better with Dr. Shiva.
Well,
and you haven't watched any of the conference.
Oh man, dude,
I've seen enough.
Well, you just said you didn't watch it at all.
Yeah, I have better things to do. I like participating.
So you just said you didn't watch it at all. This is the point that you're trying to make. You're trying to tell us something about Shiva, specifically me. Wow.
Participating in a flat Earth conference is way more interesting than watching one as an observer.
Oh yes, were you there?
No, I was not.
Then how the fuck would you know?
Because I've been there before. It's a bunch of bad math and missing variables.
Oh wow, digging those vague generalizations, man. You are just rocking it.
I'm just saying that variables are important. If you leave a variable out of your equation, it can ruin the whole thing.
Oh man.
And math is, let's face it, math is hard. And if you're really good at math, you can confuse people who are bad at math.
Dude, you know why I asked you about whether you'd even seen anything on my Rumble channel? It's because I've got literally 50 videos that involve math and many aspects of this. Well, can you even listen to what I'm saying? Or are you just triggered right away?
I don't doubt that there's math in your videos, my dude. Right?
What are you saying?
I mean, it wouldn't surprise me one bit that there is math in your presentations. My point being is that the math is not good. There are missing variables.
So you're just going to make this massive blind assumption about my content?
Yeah, if that's okay.
Oh,
It's called
Awesome.
presuming. It's called
Thanks.
presuming.
Thanks for telling me exactly what kind of clown you are.
I'm presumptuous son of a bitch is what I am.
Yeah, you made that clear. The only thing you
And somehow
ragdolled
you think
is
you were
your
going to
own
come in here
fucking
and own us
integrity.
on the fly and just wing it because we're just a bunch of dumbass flat earthers.
That's what I do every time.
That is so entertaining.
So
Thanks
you
for
said
It's
stopping
why I
by
do it.
and
It's
shitting
why I do it.
everywhere.
It's the
you
reason
said
I'm here.
something about
In a
not
total
being able to.
displeasure.
You said
Well, I
something
wish
about.
you'd get around to doing it.
I don't even have my
You ain't
computer
done
up.
it
I
so
meant to pull my
far.
computer
Hold on
up
a
for
second.
that.
Hold on a second. Hold on a second. So you said something about not being able to debate somebody, Shiva, or something like that. But don't you think you should have some knowledge on the subject you're debating?
It helps. It's not necessary.
You specifically, shouldn't you have some knowledge about what you're talking about?
It
I feel like I
helps,
do.
but not necessary. Well, Shiva demonstrated that, not that you would know about it.
I know what a horizon is.
Well, talking
You
to flat
literally
earthers
You
didn't
do
know what the
now.
horizon
not
was.
necessary.
You didn't know what the horizon was. We literally told you, and then you didn't even
You
believe
think that
that.
the horizon is where the ground meets the sky, right?
We told you
Yeah,
that.
and you learned that from a bunch of dumb flat earthers because you didn't know it when you walked in the room.
Right. So what if I'm looking at the
Right.
That's the
horizon?
simplest thing
What
ever.
if I'm observing the horizon of a giant UFO? Then it wouldn't be between the sky and the ground, wouldn't it? Be the horizon of an object that's not the ground.
Go look up horizon and tell me the definition that you
Yeah,
think best
we got a
describes
nomenclature
UFO.
problem here.
What we got here is failure to communicate. But yeah, let's go ahead and get a scientific definition of horizon.
Now,
Well,
what we
you're just-
got is
You're,
we
you're
got
telling us how illiterate you are.
yeah, we've literally got somebody in here doesn't know a damn thing, but he walks in the room assuming, well, they're flat earthers, so they must be stupid. Walks into a room and he's talking with people that he don't even know. You don't even know what a horizon is. You don't know what mutually exclusive is. They ask you for mutually exclusive, right? Something mutually exclusive to your model that proves that you live on. You couldn't even do that. You couldn't present one thing, and your confidence is way above your intelligence.
Oh no.
Oh yeah, like the room temperature is above your intelligence right now.
Oh, sick burn, bro.
Yeah, it's a sick burn. There's a reason I went to go get you. You know, you can rag. Oh, I totally ragdolled him. So I wanted to see who it was that totally ragdolled us over here last Friday.
It got recorded, didn't it?
Yeah,
No,
you didn't rag.
no, but I bet this one is.
Oh, it was.
Oh yeah,
Excellent.
yeah. This one's recorded.
So that was a really nice clapback for a flathead. I'm just wondering whenever y'all are ready to develop an experiment worth testing.
Dude,
we already have.
Gentlemen, dude, like I said, you need to check out my Rumble channel. You followed me. You know how to find it. It's in my bio.
Yeah.
And
I can
we'll
check it out,
answer
yeah.
that question because you're going to have to start off with one. It's actually 3 or 4 parts long now. It starts with something about Eric Dubé about 3 years ago now. Go that far back into my collection because they're all chronologically posted, at least reposted on Rumble. Find the one about how we took apart Eric Dubé and then we reconstructed him. And then there's a part 2 to that says Earth is not convex. And then there's the more recent stuff you'll find both right at the beginning of my collection and right at the most recent part of my collection on Rumble. Have a good time, man.
What's the best experiment you've devised so far? Because that's what scientists
For Christ's
do. They
sake,
devise experiments.
I just answered your question and told you which order to watch the videos to answer that question.
That's videos of you talking about stuff. Did you devise an actual experiment in any of those videos?
Well, don't you know the answer's yes? And that's why I'm
So
trying
what's
to
your
get you
best
to watch
one?
them.
Let's save me the time that I'm not going
For
to
Christ's
waste.
sake,
What's your
you
best
see,
one?
This is how I know you haven't watched any Shiva.
Yeah, okay. Well, it smells
because,
like you're
you know what I
running from
mean?
a debate instead of answering a question.
No, it's that I don't want to waste everybody's time talking about what I
What are
did
you
with
doing here every Friday, dude?
with the instrument landing service that you find that commercial jets and otherwise aircraft use on an approach to a runway, where we're taking a horizon measurement straight off the runway at its elevation and moving out back towards the craft, and taking, actually in the original video, I took measurements at 10 nautical miles away. Are you following me?
Yeah, that's cool.
Typical descent angle for ILS is -3 degrees, as in 3 degrees below level head as your descent angle towards the runway. You got that?
Cool.
That's going to trigonometrically form a perfect little triangle directly straight down from the craft to that horizontal line coming away from the runway, and that 3-degree down to the runway. You see that triangle?
Not. No, you lost me there.
Okay.
What's going on?
On approach, he's got an altitude. That's the vertical line.
Right.
He's got a ground distance to the runway touchdown along
Which is the
horizontal.
altitude? Which is the altitude, right?
The vertical is the
Oh
altitude.
no, the distance to the runway. Okay, got you. The
Right.
the
That's the
diagonal to the runway.
horizontal.
Okay, got you.
No,
Or
that's the horizontal. That's the
Gotcha.
horizontal. The ground distance. The ground
It's
distance
not.
to
It's
the
not.
runway
It's
is the
not horizontal. It's not horizontal to the ground. That
Well,
is.
yeah, that's what we're talking about.
tangent.
Because follow me. Let's make the triangle. Okay. The vertical is coming down from the plane and hitting the ground,
Right.
and then there's a horizontal line, but it actually doesn't quite hit the ground. Is the point?
Diagonal
It's
line.
actually the horizontal line coming straight out from the runway.
That'd be
That
the
vertical
diagonal
comes
line.
down and meets that. No, that's horizontal, straight
The
out level from
horizontal
the
line
runway.
would meet the point under the plane.
Right, straight out level from the runway.
Okay,
Straight
maybe
horizontal
that's what
line.
you're talking about. Okay,
Coming
I
in,
got you there. Okay,
meeting
yeah.
the vertical coming down from the plane in space.
Okay, I got those
great.
two established. Then you got
Great.
the diagonal of the
Now, we
plane.
got
to
the -3 degrees. That's the hypotenuse, right? Now, when we deal with ILS in a cockpit, that's the known quantity, because you're getting direct signal accurate to the 10th of a mile, 10th of a nautical mile, that tells you your slope angle to touchdown. Got it?
Mhm.
Okay, great. So you know it's a known value. So is the 3 degrees. And now we're using our barometric altimeter to confirm our altitude. And we're over the water when we do this experiment, so there's no dicking around with land and argument and obfuscation. You know what I'm saying? This experiment takes place 10 nautical miles from the airport touchdown point over water. Okay, and it's the slope angle distance that's 10 nautical miles, because that's what you're going by using the gear you got in the plane. Follow me?
Right.
Okay, great.
More
So
or
now
less so far.
what we do is we take that measurement, our altitude measurement at the point at which we see from the ILS slope angle distance hits exactly 10.0 nautical miles. Got it? It's going to produce one of two values. One that I just described to you, where the line comes straight out from the horizon of the altitude of the runway to directly under the craft, and that's your flat Earth expectation altitude measurement in the craft. Vertical line. Right. Got me? Okay, great. But at 10 nautical miles, if the Earth slopes down because it's curved, convex, curving away down, there would be a higher number on the readout.
Higher number of readout
the
of
altimeter.
the altitude.
The altimeter would show a larger number by about 330 feet, wouldn't it?
If you went up 330 feet.
No. If you were still exactly 3 degrees above the runway at 10 nautical miles away, none of that changes. Just what's happening in the ground is changing here, telling you that the altimeter reading would be different. Got me?
No, this is where I don't follow.
Well, this is the point. I made a point of drawing out the first case to you, the flat Earth case, where it's directly, horizontally, level, straight out from the runway to under the craft, vertical up to the craft, and then 3 degrees down to the runway, right? So when that 3-degree hypotenuse there is exactly 10.0 nautical miles, we take an altimeter reading.
10.0 nautical miles, take an altimeter reading, which would be your altitude.
That's right.
Right. And you're getting what? What is your number? How high are you?
It doesn't matter what it is. This is what I'm going to tell you.
See, this is one of those variables that does matter, my dude.
Shut your face. Shut your face and let me answer the question.
How high are you?
Shut
It's
your
important
face
to
and let me
know.
answer
It's
the
important to
question.
know.
Like I said, in all of my videos, I present all of the figures fully quantified. So your question is answered. I don't need to answer it right here. Just follow what I'm saying, okay? Now, once we get that value, that altimeter value, it's going to be one or the other based on the curvature drop or
No, it's
lack
going to be
thereof.
one of any values on a spectrum, right? You could be at 0 all the way to very far away from Earth.
No, it's
That's
only
your
going to be one of two
Your
things.
altitude is the distance from yourself and Earth, right?
No, dude, this is the point of the experiment. The point of the experiment is that by the geometry that I just painted out for you, between the known values of 3 degrees and 10 nautical miles from the runway point of touchdown, we have an altimeter reading and an expectation, one for this model and one for that model. And those two expectations are hundreds of feet apart, like 330 feet apart. Okay, at 10 nautical miles away. So what we do is we take measurements, and that is precisely what I did. I got in contact with jet pilots, commercial fucking pilots, and I got them to point their camera at the primary flight display that shows you all of this data live as it happens, and you take the reading from the recording. Don't you know, I've got a data path for you. It's all fully presented in the videos, and don't you know, I won't spoil it for you how it turns out. Enjoy it, but look for the one for Dubai first, and then the one that's Earth is not convex. It's about a year or so ago instead, and then finally come up to date with stuff that at the very beginning of my collection, which is the most recent, and the absolutely most recent at the top of the stack. Check them in that order, and you'll find all about the ILS experiment. Mine.
So the same way that you're
that I have for it.
Almost.
Pardon?
All right. So the same way that you're very accurately able to describe the 10 nautical mile measurement, I'm hoping that you would just tell me how high you are. There's a very long and wrong way of just telling me how high you are right now.
Dude, when I ask you for variable, it doesn't seem to be a problem that you don't provide one. When you ask me for variable, I'm providing you with detailed videos that have those variables. I don't carry them around in my pocket.
How about the variable of how high you are in that plane?
I don't carry them around in my pocket. I post them as videos for people like you to watch.
Fair. Yeah, that's perfectly fair. You take like a rough estimate.
No, dude, everything I did in those is quite precise.
Right.
Is it the one new real pilot data confirms Earth is not convex?
Unfortunately, you did not bring that math.
You got to go back another year or so.
Yeah. Unfortunately for you right now, you did not bring that math to this fight, right?
The one that says Eric Dubé deconstructed and rebuilt or something like that. If you see that one, that's
drop it in the pill. Yeah, somebody can find it and drop it in the pill. That'd be awesome.
All people have to do is check my bio. It's pretty simple. My channel's listed right there. You just go down the list and hit them. It's pretty basic. Besides, there's 50 to watch, man. Not just
this part. This particular event that you're talking about would be down there. This would be the easily repeatable experiment that you would recommend to somebody who's skeptical, right?
I'm currently seeking pilots who want to do the same measurement at 20 nautical miles, and I have an adjusted approach to the flight.
I'm surrounded by pilots. I'm a wannabe pilot, is what I am. So yeah, I could certainly help make that actually happen for you.
Then I'll forward you the proposal somehow.
Yeah, we'll run it for you. That sounds like fun.
Actually, you know what? You can actually watch the proposal. I even presented it on Globebusters on YouTube. You can watch it there too.
Yeah, if you find a link, drop it in the pill. Because I don't know what I'm looking for at this point. But would it just be like your name with Globebusters, and I can find it like that?
Well, the Globebusters is a channel, and you would. I don't know how we titled that file. It only went up maybe 2 months ago, 3 months ago. It's pretty. Just scroll down the list, you'll find it. Yeah, on Globebusters.
You can still hear me, right?
Yeah, I can hear you.
Oh, perfect. Cool. I'm on YouTube, so you can help me find it. So, Stone, how do I look your name up? You're Stone to me right now is all I know you is.
All you do is type in Globebusters and punch up the channel. Punch the live tab.
Okay.
Because these were all live streams.
Right on. I'll find you that way. Thank you. But yeah, I'd be more than happy. That in fact, that'd be fucking awesome to recreate this experiment for you and see you go live.
Well, cool, because I want to find people all over Earth to replicate this. I mean, don't get me wrong, I've already got the data from 10.0 miles. This is just icing on the cake to get some people to do at 20, because then all the arguments at either side about margin of error just flow away. You know what I mean? The numerically insignificant kind of shit.
Bending the horizon part.
That has nothing to do with this.
No. That's not yours. Okay.
It's called the ILS experiment.
Okay, thank you.
In the live tab.
I'm looking.
About 3 months ago.
About 3 months ago? Yeah, I'm already too far. Let's see. Season recap. Terrestrial refraction. Gravimetry. Stones, ILS experiment, got you locked in.
See, there you go, man. So now that is kind of a last chapter to so many other things that you should watch before that video, and they are on my Rumble channel at the very beginning.
Flight log right here. I can see your little flight. That's actually the flight you took.
All the way to the end of my collection for the most recent stuff. So what happened there? Let me explain my channel so you understand why I'm saying what I'm saying in terms of order. It's that I was on BitChute for 5-6 years and decided to not be on there anymore. So I took a lot of that collection and re-uploaded it to Rumble in September. And the first 2 weeks I had that account is right when the Shiva thing started up, and I had to post a couple of videos about that before uploading all of my stuff again from BitChute. And then since then, there are half a dozen other really recent videos. You know what I mean? In terms of the timeline, that's what you're going to see. And everything that's re-uploaded, first thing it says in the description box for each video is when it was originally uploaded. And you'll see that they're all in order. So yeah, go from there.
So it sounds to me, without looking at anything, that you're using triangulation to take 3 measurements in this experiment, right?
No, 2.
Just 2? You're just taking 2 measurements?
Yes, because the third is a known. That's the 3 degrees. The point is that you're at the point of intercept of that angle using the gear you have on board in the cockpit, the ILS indicators. Okay. And one of them tells you when you're right on that slope.
Okay. I have a feeling this is going to be a really interesting technology dive. So hell yeah.
I think you're going to enjoy it. It's lengthy.
No, I always do, man. It's a good time.
Make sure you watch part 1 first. And yeah.
Yeah. It looks old. I think there's just one on there. Let me make sure.
No, it's the one. I think it's titled Eric Dubé Torn Apart and Reconstructed, something like that. It's 3 years back.
That's something different. I'm looking on YouTube. You're talking about something on Rumble, huh?
Yeah, that's on Rumble. Yeah, that's on Rumble. On that channel, on that Globebusters channel, you'll find quite a few of my lectures. Well, the one on electrical thoughts, I think you might enjoy.
Oh, hell yeah. That sounds interesting. Is that about plasma?
I won't spoil the party. No, I won't spoil the party. You just watch that when you got some time. And the same thing with the Rumble channel now that you know how things are stacked up on that.
Right on. I know how I'm all into that kind of stuff. I have a theta wave generator, or I had one. I had to build another one now. Long story, but how were you able to I guess you did kind of simply explain your experiment. All right, so I'm gonna have to.
So when you said theta wave, did you just mean audio binaural?
No, I mean like electromagnetic theta wave generator around your head.
Oh, that's really fucking dangerous.
How's it dangerous?
It's EMF.
Yeah.
That's the point. It's fucking... okay, buddy. Have fun.
Not all EMF is dangerous. You realize that, right?
Say hi to the boys at the cancer clinic.
The Schumann resonance is EMF. You realize that, right?
Oh, man.
It's an electromagnetic frequency.
You're going to tell me about the Schumann resonance? Okay.
I'm telling you, it's an EMF. Yeah.
Okay. Where do they measure it?
The ionosphere to the Earth's surface.
No, actually, just way up high, way upper atmosphere. Okay. Now, are you keyed into its amplitude, its energy amplitude?
Oh wow! How much energy is in it? Yeah, it's a lot. I know, right?
It's a lot? How much?
I don't remember.
Like watts per meter. Do you have any of that?
I don't. What is it?
It is so insignificant. You have to have uber expensive, ultra elite gear to even detect it.
Like the big radio telescopes, right?
No, you have to be airborne. Remember, way up at the upper atmosphere, you got to be way the fuck up there to measure it. And in order to measure it, you see, this is what makes it so unapproachable and unfalsifiable for anybody like us. But I'm supposing that didn't occur to you at all.
Yeah, I'm missing your point. But Schumann resonance can be detected. It was originally detected when we started making big radio satellite telescopes, right? Pick up radio waves from space, and we got this interference.
What is clear to me is that you are not really aware of what a gigantic nothing burger the Schumann resonance actually is. But that's okay. That's okay. You'll come down the path eventually, and we'll still be here waiting. No problem, dude.
Okay, well, like your phone puts off all kinds of electromagnetic waves, right?
All kinds? No, just one kind.
Just one wave, just one frequency is coming out of our phone, is what you're suggesting right now.
No, there's a bandwidth. Are you familiar with that?
Fair enough, yeah. Oh, we got one type of wave, but with many different frequencies coming out of our phone, right?
Like I said, there's a bandwidth. Like a, 2.4 or 5 gigahertz, give or take X percentage
and our phone
of
could
that.
be emitting frequencies anywhere within that bandwidth, right?
For that purpose, yeah. For you talking about cellular, I assume.
And so that's going to be electromagnetic frequencies, EMF waves, right? So every time lightning strikes on Earth, right, it's going to send electromagnetic frequencies bouncing around the planet.
Oh,
and
wow.
It's not going to be strong enough to feel. No, you're not going to feel it. But nonetheless, it's there. And what we find in nature and biology is that it's not so much the strength of the force that matters as much as the resonance, right?
Wow.
With biology.
Dude, your sophistry is overwhelming.
Are you going to be okay, though? Does it hurt?
No, because I'm hearing nothing but platitude and stabbing in the dark.
Right. So you should listen. That's why you should listen more and interrupt me less, and you might understand more.
Oh, I didn't interrupt you at all.
Dude, are you kidding me with the interruptions? That's all you do is interrupt people. And you don't even really understand what you're talking about.
He's throwing words out there and thinking that he's sounding intelligent.
I didn't interrupt you at all, my man. I don't know what you're talking about.
It's because you're not listening.
We're listening. We're all listening.
Wow.
All right. So I think you've devised an experiment. Now let's see if I can devise an experiment to help prove the Earth is round. Just pull it straight out of my butt, like if I was a caveman, right?
Well, you see, hold on. I got to check your nomenclature again, because the purpose of experiment is not to prove that the Earth is round. The purpose of the experiment is to prove it one way or the other. That's what I described to you.
Exactly, yeah. To disprove things as well, right? And so to disprove the Earth was a giant flat plane, right? Which is what you presume, right? Like a frisbee, and a UFO, like a flying saucer in space.
I presume nothing.
Well, that's certainly going to make it hard to devise an experiment, isn't it?
Globies have the bad habits when it comes to presumption. You have to recognize that, my man.
Yeah, I don't recognize that. I think that presumption is like the stage between observation and hypothesis, right?
No, there is no room anywhere in the scientific method for presumption.
There certainly is between the observation and hypothesis phase, my dude.
I don't think you understand the word.
Which word?
Presumption.
What does presumption mean?
Very similar to assumption.
And the difference
where
being
one is based on some kind of indication and the other is not.
exactly that
Not even
indication
that much. No bit. Not even that much basis
with
on it. It is a
with
presumption.
with the indication being observable.
That's when we talk about assumption. You see?
No, no. An assumption is when you don't observe and and you make statements based off no observation. That would be an assumption.
Wow. No,
Yeah,
that's
the
the
observation
presumption.
is the key difference here, my dude, between those two things.
Oh wow, you are lost.
One's based on already repeatedly observable reality. One has none.
Are you drunk?
I don't drink. It's gonna make it tougher for you.
Well, there's only one other thing we can tack it up to then. Thanks for being honest.
How high? You couldn't tell me how high you were in that plane. What are you talking about?
Oh my God. Like I just said 4 times, I laid it out in several videos. Okay, fully quantified and graphed and charted out the yang. You're not going to believe your eyes. In
fact, should have brought that math to this fight.
Dude, why are you interrupting?
Man,
The typical advice, one sec, Bride. The typical advice I give people who watch my videos is that your pause key is your friend, because I do not waste time dicking around in production. I just get to it.
This is getting painful.
That's respectable. I appreciate information density.
Yeah. We wish you had some information, but you don't.
Well, without looking into anything you said and not caring about anything, let me just blindly fire from the hip and disagree from ignorance. Would you be all right with that? Hey, I see Jonathan's here anyway. It's a different Glober who might be cool to talk to. What do you guys think about talking to him?
Booyah.
I was actually trying to segue over to Jonathan.
Thanks for playing, Proxy. I don't know who got ragdolled here, but I don't know.
It's a great term. I'm bringing it back. It's better than dog walking.
Yeah, well, you ragdolled yourself. Or you
I'm making ragdolling sexy again.
So anyway, what's up, Jonathan? Alan asked you if you looked at something. What was that, Alan?
The papers? Have you read the papers?
Have you read the papers?
Oh shit, did Earth drop in the Epstein files?
No, your time is over and we don't talk about that bullshit here.
Oh, imagine my surprise.
Well, anyway, I appreciate you, Prox. Maybe if you had something interesting you can look up and we can discuss it later. But checking in with Jonathan right now.
How's it going, y'all?
What's up, man? How you doing?
Hey, what's up, Jonathan?
Doing all right, man.
So, you there, Alan?
Yeah. So last time we spoke, you said you were gonna check those out. Did you get a chance to do that?
Man, you deserve for me to have checked those out because you've been very kind. Unfortunately, the answer is no.
Oh man,
I have not found the time.
Jonathan, it's okay. You're the only one on the globe side that has stepped up to even attempt to understand the significance of them. So I'll give you some time.
Are we allowed to talk about aliens here?
Nah, dude, you're like everyone said, your time is over. We've spent enough time on you.
Oh, so I should just leave, huh?
Yeah.
That would be.
That would be.
Well, I gave you lots to do, man. You're going to be up all night as it is, right?
Y'all are tapped out, huh?
No,
Yes.
no,
Have
no
a
one
good
gives
night,
a
Oh my God.
No one.
No,
He wants to declare victory.
No,
You can have
guys.
it.
No, guys.
Y'all
We're
are throwing
zapping.
the old rag in, as they say,
Yes.
huh?
Yes, have a good night, sir. So, anyway, Jonathan, that issue that you had about the input and boundary conditions, assuming a globe and then homogenizing everything so that it fits a globe, you should definitely look into that so that once you've seen it for yourself, we can discuss it further.
Yeah, I did start to read that paper, and it was from 1950s, that time period or something.
Mm-hmm.
Not to put it down at all. Don't get me wrong. So yeah, I've never done. I wish I was more like you, honestly. I've never done good with papers because of the very heavy in academia kind of language, and so I get the anyway.
It's the worst.
It's not an
It's
excuse.
corrupted my brain. I know exactly what you mean.
It's painful, for lack of a better word. I do like the way textbooks present information. Again, I'm not making excuses. I fully intended to read that thing. I started reading it, and I wanted to make sure I understood. So I started digging into the first few equations it was using, and I got stumped on the first page. And so at that point, I start to feel a little discouraged. And how am I gonna understand the rest of this paper if I can't even follow what's being said on this first page mathematically? And so maybe I will take a screenshot of that, and one thing at a time we will dig into this paper. Or maybe, and this is my personality, maybe I just overthink things and I get hung up on things that aren't important, and I just need to cut right to the chase and find the thing in that paper that's important.
Yeah.
The problem is I don't know exactly where to go in that paper to see what's important.
Yeah, so the important parts are written in plain text, like for example, when they go to explain what the variables that they're using are, and also they just straight up say like, we're going to set this to Earth's radius and use concentric circles outwards to make a stratified, layer. Like it's very straightforward. Like you could conceptually understand it if you read it. I think getting caught up on trying to understand the hard pure math aspect of it is another thing, because all they're doing really is coming up with a way to like smooth data into a model using different ways to like integrate uh whatever. So you don't really need to go much further than that, but you can read in plain text where they explain it, and then like he goes over some of the important parts of how they derived air density, because air density is a big driving factor in their astronomical refraction equations, and they derive that by just watching circumpolar stars in the north and then assuming how much refraction there needed to be to explain the difference between the calculated position versus what they see. And then he was like, no one's ever tested this in the lab, and it would be super dope if we did, because we definitely have the technology now. So it's like they're all just running off of this base assumption model that's computed based off of assuming the ball. So nothing that comes out of it will, you're not going to not get the ball out of it. But you can read all that and ascertain the knowledge without doing the math for sure.
You hit on something just there, and this is kind of what we talked about in our last conversation about this is if I said that if all that's ever been done to, I guess, estimate the refractive index of air is kind of see what the stars are doing and then make assumptions. I can't remember how I put it, but if you can't, I think what I said was if you can't do this in the laboratory, I'm not really interested in how you did it in other ways. Because if you assume that the world is round, and I like to start from your guys' point of view when I'm here in these spaces. If you're presuming the Earth is round, and then you derive a refractive index based on a curving atmosphere, then, well, what if it was flat? Now your index is wrong. Well, let's just test it in the laboratory to see what it actually is. So are you saying that this has not been done in a lab? Correct. There are no papers?
Correct. There's no air density relationships to adjusting the refraction coefficients or anything like that. All these formulas are based off of people that curve fitted back in the 60s and early 70s and stuff. And even before
we do it?
Can we do what?
Could people like us do it?
Do the air density testing stuff?
Could we find out what the refractive index is via experiments?
Oh, no, they can't
directly.
They can't even do it. That's why they computed it based off of observation.
Okay, probably because the experiment would be so large scale to get any appreciable data points that you might as well just use the environment you're in.
Well, that you have to take measurements at altitudes that would require like NASA levels of funding, right? Like we would need planes, pilots, rockets, all kinds of stuff.
Okay. So right away, we're at risk of circular reasoning. You have to first prove that the Earth is round, and then go to trying to derive some refractive index based on what you know the atmosphere is resting on. It's resting on a spherical object. So, like, you know what I mean?
Yeah, it would help because
We
all they
almost
have is the terrestrial, refraction, and then, like I said, the astronomical refraction is derived purely off of observation, and they even have it like disconnected from terrestrial observations in the sense that they say that the radiative heat that creates the what's the word I'm looking for, lapse rate, that constant lapse rate that allows images to be projected into their interface level so that things can be refracted up and stuff, falls off at like a certain elevation, and the air density between that and like the stratosphere, it doesn't translate any dynamics to it. So they consider like the where they calculate astronomical refraction like an entirely different part of the atmosphere from the terrestrial, even though they're obviously related. Or obviously they would be conceptually related, but they separate them hard in the math so that they can't be mixed together.
Yeah, I'll say it again. It kind of blows my mind that I've never thought of this one fact, and that is that the only way we know what the refractive index of air is by observing stars and basing it off of what we think we know about the shape of the Earth.
Yeah.
And that's just kind of wild. We know a lot of things about material science, and this one requires a knowledge about the shape of the Earth, and that's both fascinating and kind of shocking. But yeah, just I still think how could you really couldn't do it in a laboratory. It's just the air is too thin.
I mean,
The effect the effect of refraction is too small to measure it over a laboratory or over a distance that you can, I guess, control like you would in a laboratory. I don't know.
I assume there would be some way to like, ratio out that density and measure it in the lab or whatever, but they don't even do it and even if they do it, they haven't updated any refraction formulae to reflect that, you know. Because
Dude, it's cool.
Here's the thing,
Cool to hear
like,
someone.
oh, sorry, go ahead.
It's cool to hear someone admit that, hey, that's circular reasoning and it's assumptive model and it means nothing. Well, we assume it. I've never heard a Glober say anything resembling close to that, so that was cool to hear come out of Jonathan. But also, it's cool that you're stumbling on this one. But there's many other assumptive spherical ellipsoid models where they go in assuming and then actually don't ever get around to proving the base assumption that they started with, i.e., curvature and the ellipsoid model, actual curvature of surface Earth measuring meridian arcs, and then they just go, nah, it's good, and then everything ends up being the spherical model based on just about as much backing up as you just discovered. Just saying.
Yeah, and it goes to show how important it is to know your crap, so to speak, when you go forward in science. Like you establish one truth, and then well, it all starts with paradigms, right? Something that is self-evident, or almost everyone can agree this is obviously true. That's a paradigm, and then you start building your knowledge from there. You do the first experiments, and then you establish knowledge, and then you base further discovery. And sometimes those discoveries have to rest upon those prior discoveries. So, for example, if it was discovered that the Earth was round, then there are more discoveries that exist today that are solely based on that supposed knowledge. And yeah, just a demonstration of how scientific knowledge is stacked. It's
Can
the
you give
nature
us
of
an example of that?
it. Besides, like, basing something off of the assumption that the Earth is round, or
I mean, I can
The
say
No,
that
we
we're
were
wrong.
going to base something on the proof that the Earth is round, and that we were basing something else we're doing on that
oh yeah,
proof.
it's
Yes?
presumed. Yes, it's presumed to have been proven in order for the in order for something like the refraction index of air to be then estimated in this manner.
What? Say, give me the first 4 or 5 words again. It was proved when it was proven, or what did you just say? That was ridiculous.
Oh well, so for someone to say that the accepted refractive index of air is the true refractive index of air, you presume that the Earth's round shape has been proven.
So you make a presumption. You start on that. That's very solid logical ground that you're building all this on.
I think we're talking past each other a little bit because all I'm saying is that
he's saying that's not a super cool move to do, and it's circular.
yeah. So in a way, I'm on your side in this part of the conversation. So I don't know why you're coming at me.
Okay. Carry on.
Okay, but yeah, definitely want to dig into that piece by piece because unfortunately, that's kind of how I need to do it to get real satisfaction. When I've studied things that are technical in nature, that's always been when I've gotten the most satisfaction out of it, is when I've really piecemealed it, took my time, started from the beginning, and painstakingly went through the chapter, let's say, based on, that's trying to discuss some method of problem solving and engineering, let's say. Once the light bulb goes off and I see why that has to be true, and then I start testing it out and seeing, oh, I'm wrong every time I do it this other way, but I'm right when I do it this way. Oh, and I can see why I'm right because it's consistent with all of the rules of math and of trigonometry and the things I've learned up to this point. Again, it's like the building blocks of knowledge, and then you just get that feeling of assurance. And oh, okay, not only do I see that this works, blindly, if I just trust and I use this thing, it does always work. But now I know why it works, and that's why I read these sort of things. That's why I dig into these sort of things. Anyway, I'm just rambling at this point.
Yeah, you got that right.
I put a link in the purple pill thing for you. You should be able to get to it on Celtheo. So in regards to measuring, how much refraction there is and whatnot, well, we've actually been measuring star occlusions and the mountain peaks, and when we compare what they say the refraction amount is at that time, as if there was no mountain peak there, they would say, oh, the reason the star is at this exact angle is because there's this much refraction based on our air density model assumptions and curve fitting, etc. But when it intersects with the mountain peak, it gets occluded at a specific elevation relative to the peak, that it would be off if the Earth were a globe, and it would be off by the curvature amount between the observer and the peak. And the globe already accounts for that elevation difference because globe and the celestial sphere and the terrestrial sphere become 1-to-1, so they already account for curvature for the observer in that comparison when we compare the geometric intersections. And when we compare that to the position at the peak, the globe is always off by what they already tried to compensate for. So what we can do is we can add whatever our air difference is to the expected globe drop, and we get the amount of air that the globe was off by, meaning it would cancel out. If the Earth were a globe, then we would already be off by the gamma amount, and if we added the curve to it, we would then be off by double the amount, and that's never the case. And in the links that I sent, you'll see a series of graphs that go through what exactly I'm talking about in regards to that curvature relationship. And then the other link I sent is a Gaussian distribution for the intersection differences for flat Earth versus globe, comparing each one, respectively. And the p-values there are low enough that they, the data shouldn't be rejected. So you can go through those different analyses that are on there now as well. But the important part about that refraction stuff is, they say, hey, there's this amount of refraction. Well, that would change the occlusion timing, which would change the proportional math ratio or relationship in the in the spreadsheet at the time of occlusion, and we could graph that out and we could see what that would look like. And it doesn't correspond to anything that that's asserted. So like this idea that, oh, the sun set, but it's
opening this link that you sent.
Oh,
86 peak star analysis.
You just lost Alan. Hopefully, he gets back.
Can you hear me?
The drop over distance doesn't solve the problem; it creates it. That's a pretty good line. I like how he did this over here. Trying to explain the difference between having the half gamma transversal and the full prediction of the full gamma and the arc over distance based on central angle theorem. He does would expect to show as if it were a globe. That's what it shows every time. Couldn't be clearer. Yeah, this is pretty nice.
Yeah, you like that? I spent all night working on it, dude. It's so awesome.
I immediately copy and paste it and put it on mine so I have it or whatever.
Nice.
Gaussian is bell curve, right?
Yeah, something like that.
And I think like in 3D, it would be like an actual three-dimensional bell curve. So I think that at least when in terms of like a laser application, your light flux varies by more or less a Gaussian distribution on the surface that it's hitting. Most intense in the middle, fades off in the edges. But I'm reading this, seeing how much I can readily understand here. So you said you wrote this recently?
Last night. This morning, I guess, rather. Some combination of the two.
Statistical analysis of reserve stock occlusion.
34 weeks of presentations and no one has addressed anything on that page. Matter of fact, the best refutation to date is, but you can't use distances because arc and chord. So, and nothing on that page has ever been addressed.
Dude, just aggressively never addressing the intersection differences, because like it shows, there's only one arc length, and as soon as that arc length is traversed, that's when the occlusion occurs. And so that intersection difference comparison, when we add that arc length back, we should be off by the globe drop. But we're not. Never are. Not in any single measurement. Even where some dude went to a specific spot to try and go where there's no difference between the two, the occlusion was still delayed, or the emergence rather was still delayed until the true position intersected with the peak.
I mean, it's like if you make a guess based on the Earth being completely flat, you would be right. And if you made a guess based on the Earth being curved, not only would you be wrong, but you would be wrong by the exact difference in the amount the Earth would be curved. That's the significance of it. So it's not like super duper wrong. It's triple that or whatever. It's so glaringly wrong. Anyway, dude, there was other Globers, but nobody who wanted to argue about Michelson-Morley or interferometry or how things work with axial rotation, uniform linear motion, relativistic interpretations of gravity, Newtonian dynamics versus Einsteinian, etc. None of the cool stuff.
Be right back.
I mean, all they're going to argue is whatever Wikipedia said. Not understand that and say, there it is.
That's true. But that's why it's fun to ask like leading questions now. Like, hey, did Michelson-Morley debunk the ether? I'm like, yeah, retard. Like, cool, great. Does an interferometer detect rotational motion? Stagnating effects, idiot. Like, oh, cool. Does the Earth orbit the sun? Circular rotation. Oh, no way, it does. Okay. All right. Now, why? Well, does that work with or without an ether? Can you detect circular motion with or without an ether? Of course, there is no ether. It doesn't matter. Great. So then, why did Michelson-Morley not detect the circular rotation of the sun around, or the Earth around the sun, at all? If all those things are true, well, you're an idiot. Is usually the response.
What is the significance of plus or minus 1 sigma? I know 1 sigma is 1 standard deviation, correct? Can you hear me?
I think we're just wondering what that has to do with the price of fish.
Well, I'm reading this. It says each peak shows, now each peak, so each case study shows predicted versus measured intersection angles with plus or minus 1 sigma error bars and pass-fail verdicts.
Yeah, well, Alan put that together with a lot of Dr. Mike too, I'm sure. So when he comes back, he'll answer your question on that. Or Shane will just line it up.
Yeah, I was hoping that Shane would answer, actually. I knew you probably wouldn't know the answer to that.
Well, I barely read it. He just said it to everyone. I just read it when you read it, bro. I haven't even gotten that far, but yeah, he did say he was going to the bathroom or whatever. I did say I liked it though. I liked the wording. I like how he said the curvature doesn't fix the problem; it creates it, because that's a good way to succinctly put exactly what that shows and what no one addresses and what everyone avoids.
So let me see here. So what is meant by measured intersection angles? Do you know what he's talking about there?
Well,
Shane?
when you observe an occlusion and you get a time, you use 15 degrees per hour and your position to reference that time to an angle. Then the angle you compare to your predictive angle for is the Earth a globe or is the Earth a sphere, where, those two predictions will be different. Basic arctan rise over run versus arctan rise over 1 minus drop over distance. And one of those two angles would be closer to that true angle derived from the observed time converted to that actual comparison angle. That's what geometric intersection angles pertain to. It's usually distance you are from that peak. You make it a prediction based on, is the Earth flat, arctan rise over run, or is the Earth a curve, arctan rise over run minus however many feet in curvature over that distance, just geometrically speaking. And then you say, hey, based on that occlusion time, the triangle I construct based on the angle means, is it closer to this? Or that's why I keep talking about central angle theorem, because that's the amount the star would have to traverse in both models before it gets occluded by that mountain. And when you use the prediction, the time that you're off corresponds to the amount of arc that you'd have to add that you had to correspond to the drop over distance to make your prediction different from the flat Earth in the first place.
So you start, if I understand you right, you have a true position of that peak in Cartesian coordinates, and you have what it would be if the Earth was flat, arctan rise over run. And then you have, if the Earth was curved, that peak would drop physically in space, in Cartesian space, and you'd get a lower angle. By that, rise over run. You have these two different geometric predictions. And so then
Yeah,
by observing the
because
time.
exactly, the time would be later if it were the globe that is reality. But the occlusion time is earlier such that it fits the flat expectation for that scenario for time.
And the way that stellarium is being used, or whatever reliable, or whatever, I guess from your point of view, you're using Globey's tools, quote unquote, against them, saying these are the
Exactly.
things that you guys are relying on. Okay, so then you use the time of occlusion, and then you go into stellarium and you turn off atmosphere, and then you see what the angle is to that star at the time it occludes, and you derive that angle, and now you have these three things to compare. You have the physical angle, that you have the uninterfered angle of from you to that star, elevation angle at that time, and then you have the angle to the mountain, and then the angle to that mountain if the Earth was curved. And you're just taking all of the different peaks that have been observed and all the different stars that have been taken into account with their occlusion times, and you have this body of data, and then you have these bell curves of data, and then now I'm trying to understand what you've written in light of that. So each peak shows predicted versus measured intersection angles.
Wait, did you get all that from just this page? Dude, you wrote a magic page. That was awesome.
No. Not from this page.
Oh.
This is what I already understood. And
Okay.
unfortunately, unfortunately, what you're going to get from me is I'm going to repeat myself a lot, but that's just because I am trying to get on the same page with you. And a lot of times, like, this is how I know I'm not the sharpest tool in the sheds, because oftentimes people will hear me ramble and understand what I'm talking about, but then I'll start to hear other people talk, and I'm like very quickly lost. And so,
you're scoring
for that.
You're scoring far more points than average at this point, I'd say, from what I've observed.
Your way through it seems.
Yeah, and that's really the only way I can do it. And I need the people I'm talking to be very patient with me, unfortunately. So
you're crushing.
Thankfully, you guys are very patient. So thank you. I'll repeatedly go back to the parts of this experiment that I understand, and that's what I just did. I was going rehashing that. So each peak shows predicted versus measured intersections. I understand that because you're comparing the data you're getting from the idealized world that the globe community believes in, and that is the whole stellarium gives you that angle. And so intersection angles shows. I still don't think I understand what's meant by the term intersection angle.
All right, the intersection angle is the star's true position with respect to the peak. So if there's a difference between that, then we note that difference for flat Earth. And then for the globe, because they do observer-based predictions consulting the fictitious observer at the center of Earth, we note the true position of the star at the time for the observer and subtract the difference from what they predicted their geometric peak elevation is. So we compare their model's internal consistency, right? They're like, hey, we say the stars should be aligned here for the observer and cause the occlusion. And then, they would go on to say like, oh, it was delayed for some reason, refraction or what have you. But in any case, we're comparing that difference at the time of occlusion where they would have intersected geometrically to cause the actual occlusion. You see what I'm saying?
Yeah, a lot was said there. I think I understand what you mean about the fictitious observer at the center of the world, and only reason why I think I know what that means is because in a vast universe, the Earth shrinks down to a point in comparison, And so the way we see the universe, it might as well be at the center of the planet.
No,
Is that
no. So specifically for celestial navigation and defining the geometry of the globe, they say that the stars move at 15 degrees, or I'm sorry, 60 nautical miles per degree at the sidereal time, right? So, you know, a little faster than 15 degrees per hour. So to get that calculated position, right, they have a snapshot of where the stars were on the equinox, and then they just add 15, you know, they add sidereal time to that reference point. So anytime you see a star, you're consulting where that true position would be, you know, only considering the 15 degrees per hour, no refraction, things like that. And like that comparison though, like to maintain that 60 nautical mile per degree linear rate, they have to, you know, say that they're looking at a fictitious observer at the center of Earth to merge the celestial sphere and the terrestrial sphere together to get them to move 1 to 1. Otherwise, they can't say that the star's change in position is due to Earth's geometry. The only way they can do that is by putting a fictitious observer down there and making all observations relative to that observer. So we see the star at some angle at a time when it's supposed to be at a different angle. Oh, well, the difference must be refraction, is what they say. But they're always consulting that observer at the center of the Earth, meaning comparing, you know, where it would be with idealized sidereal time with no refraction, following that same rate, which would happen to give you a ball with a radius of, you know, 6,731,000 kilometers or meters. Sorry. And so what we do, right, because they've got their observer centric model. Oh, did I lose audio? Can you guys hear me?
I hear you.
Okay.
And
Good to
unfortunately,
go.
my wife did ask me a question through the door
Oh,
there, so I couldn't hear everything you were saying. I'm sorry.
no worries, no worries. Where do you want me to back up to?
Um,
So
I think
the,
she
the,
pretty much poked her head in right as you started explaining that. I'm so sorry.
okay, no worries.
So I thought I understood the whole purpose for invoking an observer at the middle of the planet. Where does that come from again, and why is
That
it
com-
used?
that comes from the two-sphere model for celestial navigation given to us by Ptolemy and the Chinese, etc. But
Okay.
basically, you have to have an observer at the center of Earth, and then you consider the positions of the stars on the surface of Earth. So you create like
Mhm.
uh, you know, a 1-to-1 model based off of how they're going to move with respect to that radius as they're going to arc in the sky from you. So, and
Mhm.
that rate is 60 nautical miles per degree at sidereal time.
Mhm.
So,
At
all
sidereal time.
yeah, it's a little faster than solar time. So when they go to see like, hey, I know where this star's geographic position is, well, when they're looking at it based off of what angle they're looking at it, they have an amount of refraction that should be at that angle. So there's this, so that they can explain the separation from the angle that they see the star versus the angle where the star should be following the 15 degrees per hour, 60 nautical mile per degree relationship, because they're basically, you know, whether it exists or not as a physical location, they need a reference baseline for it to be, you know, to have, and then look at the deviations from that to compare it to.
This may sound like a dumb question, but if I can't transport myself to that part of the world where the star is directly over my head, and then warp back to where my telescope or where my observation is, to compare, okay, I've moved this many degrees. Of course, then that assumes the Earth is round. So, getting my brain all tangled up right now. Um, how does using the concept of this one-to-one star position on a spherical Earth, how? Because shouldn't it be that all we need is, how do I say this? All we need is where the star should be if there's no atmosphere, no refraction, and then where we observe it to be. And then we'll see now where I'm headed is, I would use the refraction of air, but then the refraction of air requires knowledge about the Earth's shape.
Well, just comparing it to where it should be is that process of using the fictitious observer to get that to maintain that linearized rate. Because as you know, as the stars and the sun and anything, as it gets lower in the horizon, it starts to linger, so it doesn't follow the sidereal rate of change for that angular drop to maintain 60 nautical miles per degree. So what they've come up with is like, oh well, that must be because there's this much refraction between the two. So any astronomical observation is done with respect to defining the true position of the star, of the light source, not what you see, but where it should be if you had a fictitious observer at the center of Earth that had a direct line of sight to the star. That angle created from that observer to that star where it should be defines where that ground position, or I'm sorry, where that geographic position is going to be defined. So that's what gives like the whole system relevance. It's not based on the apparent position per se. It's based on the conceptual deviation from the true position versus what you see. So in any case, because they have that relationship established, that's how they can know that's how they can relate angle to time, and then know where any star's angle should be at that specific time. It's all bound to that fictitious observer at the center to maintain the linear rate of 60 nautical miles per degree.
Okay,
So
I'll have to think about some more for sure. And
let me read you this quote real quick from
okay.
a CellNav book and see if it makes sense. Okay. Fictitious. All right, here we go. As soon as I can find it. All right, sorry about that. I'm having trouble finding it.
No, take your time.
Here we go. Okay, calculations of celestial navigation always refer to the geocentric altitude of a body, the altitude measured by a fictitious observer being on the plane of the celestial horizon and at the center of Earth, which coincides with the center of the celestial sphere. So when you make an observation, you're looking at the apparent position, you're on top of the terrestrial sphere. When you subtract the refraction out for the angle that you're viewing the star on, because every 10 degrees of angle there's a basically a predetermined amount of how much it has to be. So anyway, you subtract that amount based on the angle, and that comparison there, you're now referencing where it should be at the fictitious observer at the center of Earth to define that geographic position. So you're basically changing the angle to what it needs to be. I could post a screenshot of that in the.
Yeah, please do, because then I can stare at the words and make the text repeat itself instead of making a person repeat himself. That'd be great.
Yeah, no worries. But yeah, anyway, the conceptually the backbone of all of astronomy is based on geocentric positions of celestial bodies, and then like when those line up, they'll be like, oh, that's when there's going to be an occlusion, that's when there's going to be an occultation, that's when there's going to be a an eclipse or what have you, right? So like they're all based off of this unrefracted idealized position following 15 degrees per hour at that linear rate. So that's what it's all about. So when a star gets occluded by a mountain, then we should be able to reference its true position, when it lined up with that mountain peak for the observer, and the globe predicting that, how they use the celestial and terrestrial sphere together and how they make it 1-to-1 with the fictitious observer. They predict that the sky drop, has already occurred for the observer, so it's already going to be at that lower elevation essentially relative to the observer at the end of that arc length. So as the star gets lower for the observer, it's already going to be lower by the Earth curve amount relative to a flat plane. So when we compare, when we go back to that occlusion that happened for the observer, and then we look at where the star was lined up for the mountain peak, well, when we traverse that distance, essentially, we're adding the arc length back between us and the peak, and so that's
When
going
you
to change.
traverse that distance on Earth, if you were to
Yeah,
take a hike,
yeah. If you were to traverse the distance, the star's elevation would change relative to how far you traversed. So
yeah.
when we add that arc length back, we should be off by the amount of Earth curvature between us and the mountain peak, and we never are. The globe is always off by that amount every single time.
Oh, okay, yeah. So you're saying that if there's a star close to the horizon, I can't raise that star up by the same amount around my celestial sphere as I'm going around my supposed Earth, because it's going to be moving slower. It's going to change slower for the same reason that it slows down as it begins to set.
No,
Like,
no. What I'm
okay,
saying is, on the globe, the true position of the star at the time of an occlusion should be at a lower elevation than on a flat Earth by the exact amount of drop over distance to the peak, or like, of whatever the distance is.
interesting. Okay.
Yeah. Yeah. And then so when
I
we
wouldn't have
look,
expected that,
yeah,
but I'm trying to wrap my head around it.
well, it's all related to central angle, right? So the central angle between you and the peak, there's a
Hmm.
half central angle, and that half central angle just so happens to always be the drop over distance of that arc length. So if you add the arc length back and there was actual terrestrial curvature, then the star relative to the mountain peak, it would have already been occluded because it's already at that lower angle of the curvature. So when we add it back, it's going to be above the mountain peak by that curvature amount because it didn't get a chance to get lower relative to the peak to be intersected by it.
Hmm.
So if the observer-centric position, as defined by globe geometry, is correct, then the uh, then the amount of curvature that they predict between us and when whatever peak would be the amount of difference between our measurements, and it's always the reverse, meaning the globe accounted for something terrestrially that's not there. And then so the graphs that I have show that relationship where if you add the intersection difference predicted by flat Earth to the amount of terrestrial drop over distance, you get the intersection difference that the globe missed their drop by. And if the Earth were a globe, then the intersection differences would be reversed. So the globe would be, closer to the prediction. Flat Earth, when we add the arc length back, we would be off by the half of the arc length, and whatever the elevation of that would be, we would be off by half of it. And then when we add the globe drop in, we would be off by that as well. So we would be off by double the amount of globe drop. So it shows how the globe is accounting for like a terrestrial elevation difference that isn't present in reality. Otherwise, we could never make those alignments that we're doing. We're basically making congruent triangles that should be impossible on a globe.
Hmm. Man, I wish I was smarter. I'm gonna have to go up to the top of a mountain, guys. I'm gonna sit in Indian style and meditate, and 10 years later, I'm going to say, "Ah, now I know what he was saying."
That's essentially what we've been doing for the last year.
10 years later, great band.
What's the band called again?
10 years later.
It's called. Okay, I was trying to think which set of words was he referring to. There's so many weird band names out there. 10 years later isn't bad, I guess. 10 years later, you can almost Google any phrase and discover there was once a band called that.
But yeah, in every case of astronomical prediction where they're like, oh, there's going to be an eclipse, there's going to be this, there's going to be that, they do it based off of geometric intersections. And when we do that, the globe's off by what they predict as literal drop over distance. It's pretty crazy.
Yeah, look up their song, I'd Love to Change the World.
I literally typed in Jumping Pumpkins to see if there was ever a band. Like, that was the first random phrase.
Oh, there's a Smashing Pumpkins.
I know, that's what it brought up. I'd Love to Change the World by 10 years later.
Classic.
So 10 years, how long ago did they write that?
Many years ago.
Okay. Did they end up changing the world? 10
Let me
years,
check
10
the
years,
date on
10
that.
years
I
later.
can tell you.
10 years after they wrote the song.
All right, lads. I've been live for about 3 hours. I'm gonna head off for the night.
Appreciate you.
Well, thanks for stopping in there, man. So what do you think there, Jonathan? It's pretty devastating to your globe, right?
Oh, real
No,
quick.
I'm just trying to understand what he's saying. What?
Real quick.
It was 1971.
Before we devastate the globe, I have a debate on the 27th with Astronomy Live at 9 p.m. Eastern. We're going to be debating the celestial theodolite.
Holy.
So tune into that. It'll be hosted on Red's Rhetoric's channel, but it'll also be restreamed on mine as well. So at space_audits for that on YouTube. And then we'll be back again on Monday for the actually, wait a minute. Is Sunday the 1st? Are we gonna be? Yeah,
yes, it is.
Yeah, we'll be back on Sunday. We'll be back on that Sunday for Globebusters season premiere.
Is that a fact?
That is a. Oh well, surprise!
Yay!
Well, I asked you last night if you were ready for the return on the 1st, and you were anyway. So yeah, so double surprise now. So anyway, we'll be back on the 1st for that. And then Monday we'll be live for Celestial Theodolite Update 38 on Earth Awakenings. And then we'll do whatever we're going to do on there. And then Tuesday we'll be back with a presentation on something for Aether Roundtable, number 121.
Nice.
All right, later, lads. Have a good night,
You have a
everyone.
good
All right, thanks everyone for stopping by. See you guys on the next one.